Yes, sir.
Professor Indranil Mannaji, Vice Chancellor, Birla Institute of Technology, Mesra Ranchi, and of course former Director IIT Kanpur, uh, past presidents, vice presidents, my council colleagues, corporate members of IIT, distinguished guests, ladies and gentlemen. A very good morning to all of you. I welcome you all to the 34th Dr. Amitabh Bhattacharya Memorial Lecture, instituted in the memory of Dr. Amitabh Bhattacharya, an eminent educationist of the country and past president of this institution. He was the director of IIT Kanpur. Today, we are happy to have with us Professor Indranil Mannaji, Vice Chancellor, BITS Ranchi, to deliver the 34th Dr. Amitabh Bhattacharya Memorial Lecture during this auspicious occasion of 40th Indian Engineering Congress. A lecture during this auspicious occasion of 40th Indian Engineering Congress. I now request Major General Dr. M.J. Syali, Secretary and Director General of the institution, to formally present the background of the memorial lecture and also to introduce the distinguished speaker. Thank you.
Thank you, sir. 34th Dr. Amitabh Bhattacharya Memorial Lecture. Dr. Amitabh Bhattacharya, President of the Institution of Engineers India during 1976 to 78, occupied the center stage in the affairs of the institution for over 2 decades. A many splendors personality, Dr. Bhattacharya's untimely death in June 1992 created a void which would take years to fill in. In grateful appreciation of the monumental work done towards furtherance of the cause of the institution, the National Council at its 563rd meeting held at Hyderabad resolved to institute this lecture to perpetuate his hallowed memory. Born on November 12, 1931, Professor Dr. Amitabh Bhattacharya was a distinguished mechanical engineer and an eminent educationist and an acknowledged authority in the fields of production engineering, metal cutting, and machine tools, and had been honored nationally and internationally for his outstanding contributions to the cause of engineering and humanitarian services. He was a staunch advocate for the development of indigenous technology for the welfare of the common masses. A persuasive teacher and eloquent speaker, he had traveled widely on many professional and academic assignments. An active and constructive social worker, he identified himself with the aims and aspirations of the numerous social and cultural organizations and served them with great distinction. As an ardent advocate for advancement of engineering, Professor Dr. Bhattacharya served its cause through various organs and activities of the Institution of Engineers India for 3 decades. During his presidentship, the institution's activity received an impetus and diversified its field of interest in many areas, including the rural development. About the speaker, I am honored to introduce our distinguished speaker for this prestigious memorial lecture, Professor Indranil Manna, Vice Chancellor of BIT Mesra, an eminent materials engineer, educationist, and national leader in engineering research and policy. Over a 4-decade career, Professor Manna has held several pivotal positions, including Director IIT Kanpur, Director CSIR CG CRI, past President of INAE, and currently Vice President, Science and Society of INSA. He has played a major role in national initiatives on engineering education and translational research, most notably leading the Government of India's imprint program. A graduate of Calcutta University, IIT Kanpur and IIT Kharagpur, Professor Manna is internationally recognized for his work on phase transformations, nanometric materials, laser and plasma processing, and ferrofluids. He has published over 325 research papers, guided 30 PhD scholars, and executed numerous major sponsored projects. He is a fellow of all leading national academies of science and engineering, a fellow of TWAS, and a recipient of several distinguished honors, including the TWAS Engineering Services Prize, INSA Young Scientist Medal, AICTE Career Award, and National Metallurgist Award. His global research engagements span institutions across Germany, USA, the UK, France, Japan, and Singapore. With these words, I am pleased to welcome Professor Manna and invite him to deliver the memorial lecture.
Very good morning to all of you. President Engineer Singh, Secretary Major General Siali, the eminent engineers and members of Institution of Engineers and friends. I feel deeply honored to be invited to speak in a commemorative occasion dedicated to the memory of Professor Bhattacharya, who we all hold in very high esteem. But I have chosen a topic which is, in my opinion, very relevant, very important today. We all are aware that the Honorable Prime Minister has set a target before the nation that India must emerge as a developed nation by 2047. In about 22 years from now. So the very first thing, in academia we often say this to our students, that particularly to the research scholars, that a problem defined is half the problem solved. So we must understand where we stand today and where we wish to reach in about two decades from now. So what is very important for us to know exactly the coordinates of today and the coordinates of tomorrow, where we wish to reach. And instead of claiming something which is very doable, very easy and so on, as members of the learned body, we all must understand what exactly are the important Yeah, so basically if there's no quantifiable parameter or number by which you may say that this is the threshold. If you're above this, then you are a developed nation, and if you're below this, then you are a developing or an underdeveloped nation. But I did my own homework and I realized that at least there is something which we can refer to. Majority of the nations like US or Scandinavian countries, most in Europe, or for that matter Japan and so on, they are above a certain, in terms of a particular scale called Human Development Index, they're all above 0.8. And that's in general, that's a well-accepted parameter that if you're above 0.8 out of 1, 80% of that yardstick, you're considered to be one among the developed nations. And this, India's current score is somewhere just above 0.6, 0.659 or something like this. So we have a long way to go. And also because we occupy I have a bad habit actually, being a teacher, And I must say that, let me make no bones about it. Um, you're all professionals. This is one element of very unprofessional behavior, which we all, in our course of career, should try to, at least practice this level of the bare minimum respect that you can show to anybody who you invite. So the journey, if it is to take above a certain threshold, so we should know exactly what we are talking about. I'll come at the right end of the talk as to what is HDI and where do we stand and what we need to do and where other nations actually are. So I have the privilege of wearing two hats at least. I still am connected with IIT Kharagpur. My 40-year-long association will end at the end of next month. So early end of the next month, I'll superannuate from IIT Kharagpur after 4 decades of serving that institution. And I'm very proud to be part of Birla Institute of Technology, Mesra, which happens to be the third oldest institute of technology in the country post-independence. Many of you may not quite aware, but because all of you are engineers here, you should know that after independence, the first engineering institution founded, of course I'm not referring to Roorkee and BE College and so on, who have more than 150 years of history. Post-independence, the first engineering institution founded in the country was Bihar Institute of Technology, Sindri. The second one was IIT Kharagpur, and the third one was BIT Mesra. And we, in the lighter vein at BIT Mesra, we often tell others that we are older than all IITs and similar institutions in the country except IIT Kharagpur. So that way I'm very proud that I'm associated with both IIT Kharagpur and BIT Mesra. We just heard a reference to Professor Bhattacharya as a former president of your Institute of Engineers, which certainly is, in a long history of this institution. By the way, I'm also a very proud member, life member, and a fellow of Institution of Engineers. So when I got this invitation, there was only one reason why I immediately agreed, and that's because Professor Bhattacharya. Those in the academia, we all know that, I'm talking about I think he was born in 1930s, 34 or so. And so when he entered into the profession, at that era in 1960s, 70s, to be able to create a new department, a completely new subject domain, that too in a very reputed institution like Jadavpur University, and having having headed an institution of the reputation of IIT Kharagpur, IIT Kanpur, it speaks volumes of his level of eminence at that point of time. He was Bhatnagar awardee, and he was fellow of Indian National Academy of Engineering and Indian National Science Academy. Now, that apart, I actually, are you able to see the screen? Yeah. He was one of the youngest, not the youngest ever who has served as a director of an IIT was Professor C.S. Jha, who was selected as director of IIT Kharagpur when he was 40. Professor Bhattacharya was made director of IIT Kanpur when he was 44, one of the youngest at that point of time. And I'm talking about mid-70s. And he served as director between, there's a small correction, not 75 until 79. I got it corrected today morning from none other than Professor Amitav Ghosh, who happens to be a former student of, PhD student of Professor Bhattacharya, and he himself served at IIT Kanpur with a very long career and also was director of IIT Kharagpur. So Professor Bhattacharya served between 1976 and 79. He resigned on some matters of principle. So all I'm trying to say is that we have glorious past and glorious legacy, which we often not just tend to forget, but even fail to honor. Professor Bhattacharya was such a towering personality you rarely find today. I just mentioned these few elements of his contribution to create a subject domain which didn't exist in this country, to head one of the topmost institutions in the country, coming from an institution which certainly was not in the same league, and then to be able to serve for a number of years, and then also contributing to the engineering fraternity as president of Institution of Engineers for a number of years, and getting recognition from within the country and abroad from multiple sources. So I certainly, like all of you, would like to pay my deepest respect and homage to this towering personality. And as I said, that's the only reason why I agreed to. I landed in Calcutta yesterday late night, and I had to take 6 o'clock train this morning to reach here on time. So let me now devote to the entirely engineering for a while and then switch to the developmental aspects. We all are proud of this achievement that happened 2 years ago, little over 2 years ago. In fact, I had the privilege of, in fact, this slide was actually shared by the then chairman of ISRO, and I happen to know many of them, and so the first thing that I wanted to mention here is that this is a system success. It is not a success of one rover landing on the surface of another planet and collecting some data and sending us. To be able to send a rocket carrying a vehicle loaded with sensors, cameras, and devices to a place where nobody has ever set foot on until now, and also no one else anywhere in the world would have even attempted to go and land there, was a monumental success for the nation, which either has never happened or has rarely happened in the past, in the entire history of our country. So this is a glory that each Indian would take pride in celebrating and remembering. Because in most of the cases of science and technology, there's no harm in admitting that we generally do catching up job. Someone else has done it, and we do and say, claim that we have also done it. So instead of saying that we have also done it, this was a very rare occasion when India could say that we have done it before anyone else, to land on the southern hemisphere of the moon. And this soft landing and the correct landing was in the third attempt. So India already suffered 2 unsuccessful attempts, and yet in the third occasion emerged as successful. So that shows the grit and courage and dedication of an organization manned by professionals like us. And we all are aware that ISRO is an organization which has not just engineers. In fact, any successful, any complex system always requires input from various engineering disciplines. If you look at an aircraft or an automobile, nobody can claim only aeronautical engineers and mechanical engineers make an aeroplane or an automobile. You need engineering from all quarters, and you need input from beyond engineering. So ISRO is a bright example. So now the question is that in order to achieve or reach that level of success, which makes you as the first ever, it's not an easy job. And it doesn't happen at the click of a button. It happens over decades of very, very serious efforts. And I see here also another connection that I'm very proud to mention, that BIT Mesra has a department called Space Engineering and Rocketry, and that was founded in 1964, and ISRO was founded in another 5 or 6 years hence. So that way, you can imagine that what level of contribution these institutions would have made over the years. So the forefathers of PIT Mesra understood the importance of space engineering and founded a department even ahead of country instituting a department called Indian Space Research Organization. The same reason why I personally feel that Professor Bhattacharya's contribution is monumental. By the way, I found two specific connections between me and this legend. Number one, he did masters from the institution where I took my graduate degree, Bengal Engineering College, and he served as director of IIT Kanpur, which I had the privilege of also serving, first studying there for my masters and then also heading that institution's administration for a while. Whatever we see as a successful implement today in the domain of science and technology, whether it's a very tiny little sensor all the way to a rocket which goes all the way to the outer space or even reach moon, we must realize that the foundation is always fundamental, and that's science. And in my simple understanding, I claim that science is nothing but a simple why. For anything and everything around us, if we raise a very fundamental question as to why something happens this way and why not another way, without caring or bothering to know whether this is going to be useful or not, whether the answer is going to be useful or not, then this is exactly the exercise called science or pursuit of science. So science actually unravels the mystery between the relationship between us and the nature or various natural phenomena that we see time to time. So once in a blue moon, we see the output of science as very major breakthrough or discovery. So for example, Alexander Fleming, seeing that from the microbes, certain species develop which actually kill the other microbes. And he just asked himself the fundamental question as to how come this set of species is able to destroy another set of harmful species. So that's the birth of antibiotics. And we know today that the entire history of humanity, civilization, would have been very different if there was no antibiotic. Of course, we misuse antibiotic to a large extent today. That's a different story. But the birth of antibiotic was essentially a very scientific question as to why a set of microbes actually are able to destroy or prevent another set of more harmful microbes to grow. Similarly, when you see today electricity all around, so it took the genius of Faraday to ask a fundamental question as to, if you apply a potential difference, why should electrons flow from one potential level to another? The birth of electricity. Imagine humanity today or civilization without electricity. Of course, not Faraday alone. There were many other, Volta and so on, who would have contributed. But I'm just taking examples as to what is fundamental science. Now, then engineering is the translation part. When you know electrons flow, and when you know that electricity can make certain motion or certain conversion of one form of energy to other, and you can make use of that to drive a vehicle or heat a machine or rotate a fan or something like that, then you make use of that. So the fundamental is the electricity, and the application are those devices. And who do this? These are done by the engineers. So engineering is nothing but translation of fundamental knowledge into viable applications, useful applications. But then if you show something happening and you know this is viable, sitting here in Durgapur, the civilization in the rest of the world will not be able to reap the benefit of that unless it goes through a stage of commercialization. So there comes the need of the final translation, which takes the development to the marketplace. So from know why to know how, and eventually to know what sells in the market, is the cycle called science to engineering to technology. And this actually is never unidirectional. There are multiple examples which proves that technology also drives science. Today we are in an era of artificial intelligence, and artificial intelligence borrows the inspiration from the human evolutionary science or evolutionary algorithm, and is able to provide us solutions which are not based on a fundamental equation. So it is learning from the trends and is able to predict, even before you key in the full sentence, you get an answer. So basically, you have created a model based on the data available, large language models and various other models, that when you are trying to type distance Howrah Durgapur, so even before you have completed the sentence, you immediately get an answer that the distance is so much, takes so much time, and so on. Logically, exactly what we would like to see. So technology also generates certain new questions as to how this can be made more efficient, more faster and cheaper and so on. So in academia, we pursue knowledge. We either create by research or we disseminate by teaching. The research organizations, they pursue inventions. The industry takes them to the marketplace as viable technology. And this cycle is a closed loop and continuous, because then the customers, we, the members of the society, we continue to demand more and more, or faster, cheaper, better, and so on and so forth. So this is the modern ecosystem of innovation. I'll skip this part and I'll take you to a very important status that we are in today. Many of us tend to believe that the moment you say India or Bharat or whoever, at least to the foreigners, it appears to be a country which is like a monolith. But India is a very complex and a very interesting canvas, like the way I've picked up. So these are, as you travel, let's imagine from Itanagar to Gandhinagar, or Kashmir to Kanyakumari. So in this entire stretch of east to west or north to south, several thousand kilometers, every 100 kilometer you travel, or maybe every 200 kilometer you travel, you see the complexion of the human being, the language, food habit, climate of that place, various practices, culture, attire, dresses, everything changes. So India is actually a very complex and a very unique blend of various kinds of people, all anthropological origin, people of all anthropological origin exist here. People of all possible religious connections exist here. So if we want to make a difference to this country and declare this country to be a Viksit Bharat, then first we must know what is the role of, where do we stand, and what are the challenges, and who are we trying to offer certain benefits. So in all this, I certainly would like to quote, and this is the phrase that all of us are aware of. Years ago, what Rabindranath Tagore said, and that's absolutely true, that India is actually a land of unity in diversity. So this is something which is very paramount, that we all must realize, that when we say India, we actually must realize that the societal needs, the climatic conditions, the challenges are very different from one segment or one location of the country to another. So one solution fits all will not happen. So we are talking about a country which has a very long history, more than 5,000 years, at least 3,000 years of recorded history. Used to be one of the richest nation until the early part of 18th century. And we are a mighty fifth largest economy in the world with 4.2 trillion or even more. We also happen to be the largest and the youngest population in the world. We were the 8th in the nuclear harnessing category nations. I don't know whether you're aware or not, we are the largest producer of drugs and pharmaceuticals, the second largest producer of steel, cement, coal in the telecom sector, food and agriculture. We are the fourth largest producer of automobiles in the world, third largest generator of electricity. And the good thing is that the electricity, what used to be hopelessly dependent upon fossil fuel, today is nearly 50-50 in fossil fuel and renewable resources. So we are also a nation which supports the IT infrastructure in the whole world. But then there's a flip side. And this is the flip side that I wanted to make you all aware of. There's a huge diversity, 37 states and union territories, 22 official languages. If you count the dialects, it could be thousands. 8 main religions, all those traits exist in this country. Then, while we are the 5th largest economy in the world, there's no denying the fact that the per capita income-wise, India occupies a barely 138 or somewhere around that out of 170 countries or 190 countries. So this is one very important part that we all must realize, that in India, the challenge lies not in the numerator. We are a mighty economy. We talk about trillions of dollars. We, in terms of number of cities, number of people, number of various implements, there's no dearth. But when you divide by 1.42 billion, when you calculate anything per capita, then the true picture emerges. So if you say we want to be a developed nation, it's very important that we first understand that for every nook and corner, for every member of the population, unless we can raise the level of living standard, we cannot claim ourselves to be a developed nation. What I started talking about, and probably I digressed a little bit, let me come back to that point. Human Development Index actually has 3 components: education, health, standard of living. So in these 3 parameters, if you actually can raise the level of the common masses to a level above 0.8 out of 1, then you can call ourselves a developed nation. Now, I've chosen certain numbers and important parameters. I'm not going to talk about all of them, but just look at this. This is important, maybe just 1 or 2 of them. 1947, when India earned its independence, the GDP was at, in terms of rupees, 2.7 trillion. Today we are at 262 trillion when you convert dollar into rupees. So this is the kind of number you are at. So you see there is, you can easily see there are 3 orders of magnitude improvement. Okay, obviously the population was 34 crore. Today we are talking about 142 crore. The per capita income was merely 250 rupees. Now we are talking about 1.8 lakhs. I mean, $2,500 converted to rupees would be this much. So in terms of per capita energy consumption, again you see 2 orders of magnitude improvement. India produced only 1 million ton of steel at the time of independence. Today we produce 125 million tons of steel, though the target is 3 times more than that. But still, you see there again 2 orders of magnitude. So in terms of health, the child mortality rate out of 1,000, how many children die at the time of birth, life expectancy, in many of these counts, India has done enormously well. And thanks to the intervention by individuals like Professor Swaminathan, for which we got Green Revolution, Korean, because of Dr. Korean, because of whom we have got White Revolution, and so on and so forth, India is a food surplus country today. Okay? But the fact remains that the distribution is still very poor. Still people die out of hunger in this country, despite the fact that so many metric tons of food grains are wasted and rotten and thrown away every year. I have also chosen certain parameters to compare. If we compare ourselves with nations which are to our west and to our east, US, China, Korea, Sweden, and I've chosen 3 important parameters. Energy consumption, there's no development, there's no progress without energy, right? For anything, wherever we want to make progress, whether it is in education sector or industrial sector or even pursuing creative activities, we need energy. So energy consumption is a very important parameter of economic progress or development, state of development of a society. US, the level is about 8,000-9,000. China, it's about half. India is 1 order of magnitude lower than that. In fact, this is about 30 to 33%, 1/3 of the world average. So if India today consumes or produces about 400 to 450 gigawatt hour of electricity, and that with that we are able to reach to various distant places in the country, various villages and distant corners, still it is insufficient purely because the world per capita consumption is 3 times higher than what we are doing. Now imagine if India right tomorrow by some magic starts producing instead of 400, 1200 or 1400 gigawatt hour of electricity, and by today's rate nearly 55-60% coming from fossil fuel, how much more carbon dioxide will emit to the environment? India already is the 3rd largest emitter of CO2. In fact, you see the very next row tells you that while US emits 15 metric ton of per person of CO2, we emit much lesser than that. Much lesser than that. But yet we are the 3rd largest emitter of the CO2 in the whole globe. And why does it happen? Because there's a multiplier of 1.42 billion. So small difference in this country. Why are all these big nations, developed nations and big multinational companies, why are they so keen to come to India? Even the topmost institutions, educational institutions in the whole world, they always are very keen to come to India and for collaboration. And that collaboration, I always point out, usually is always unidirectional. They all want to come to India only to grab the best students and best talents to serve them. We have been doing that for ages. I think it's now time that we realize that that's not the way India can emerge as a developed nation in the future. So what we need to do is we have to change the trend. So what I'm trying to do here is to make you aware that when you compare yourselves, this is also something as members of the learned body, we can surely expect that while we handle a very important device in our hand, we also should know that there is a button, there is a provision which allows us to make it silent. Very simple, device. If we know how to switch on and switch off, at the same time, it should be also mandatory to know how to use that and not to misuse it. Now, I've also chosen one other country to compare ourselves with, and that's South Korea, the Republic of Korea. Why is it so? Because I don't know how many of you are aware that we have few things in common, and striking coincidence, we share the Independence Day, same 15th August, only 1 year ahead. Korea got independence in 46, we got in 47. And Koreans believe, I myself actually came to know when I was visiting Korea, very interesting. They believe that 1/4 of their population carries Indian blood. And you know why? Because one of their earliest kings, whose surname was Kim, was married to an Indian woman, Indian princess. And I was told the princess came from Ayodhya. He wasn't sure whether it is Ayodhya or something else, but they still strongly believe that the princess came from India, and Korea typically, you know, you will always see Lee or Kim or some of them. So the Kims are almost 1/4 of the population. So they believe that about 1/4 of their population have Indian connection. Anyway, leaving aside those, the important thing is that, look, so we earned our independence around the same time, and so we have a journey of around about 75 plus years. And where do they stand in terms of Human Development Index? In 1950, India was at 0.434, Korea was at 0.738. Today, Korea is 0.937 and 4th in the world. And India is at 0.685, which places us at 138. The gross enrollment ratio at the tertiary level, at the time of, not at the time, 1971 was 5% in India and 7% in Korea. Today it is, we claim 30%. I honestly doubt whether this number is correct. It could be anywhere around above 20%. Korea, it's 103%, which means in a given age group, if 100 people live in that particular age group, or if that age group comprises 100 individuals, all 100 of them are educated. And in fact, it's 103% because some of them are having multiple degrees. So in terms of government outlay on education, India has raised from 2.4% to 4.1%. Korea also has raised it to 4.9%. But what is remarkable is the next row. India's outlay in research and development in 1996 was 0.64%. Today it is 0.65%, only 0.01% increase. Korea invested 2.2% of their GDP in R&D in 1996, and today it is 5.21%. So you see the outlook, the difference in the outlook of the nation. In many other respects, if we publish 64,000 patents in a year, last year, Korea published 1 order of magnitude more, 289,000 patents in a given year. So that is the reason why Korea's GDP per capita at the moment is 33,000, and India's per capita is 2,600 or 700. We often compare ourselves with China. In fact, I purposely didn't pick up China because situation will be even more depressing. Let's not worry so much about these numbers. Take the case of energy. We have made progress, and very resounding progress, very significant progress. India, I don't know how many of you are quite aware, our president of the institution served a long time in power sector in UP. I am sure he is aware. India is the 7th largest producer of electricity through hydroelectric route. 3rd largest number of dams we have. The environmentalists are certainly not very happy about it. We have a large solar energy installed capacity, and only the other day I learned from a very learned colleague that today the contribution of solar energy to the national grid is more than double than what it used to be 10 years ago. In fact, India has made enormous progress in terms of solar harvesting. So India carries the 5th largest coal reserve, but India also uses a lot of natural gas and other sources. So let's skip that part. So 10 years ago, about 10 years ago, India's energy mix had more than 2/3 dependence on fossil fuel. Today it is roughly about less than 50%. So roughly 49% from coal, slightly more, maybe 51, 52% from the carbon resources, fossil fuel resources, and the rest are from various mix of renewables. Wind, hydro, solar, biogas, and several others. So we have made reasonable progress in that. But then the per capita consumption, as I said, is only 30% of the world average, not compared to the topmost nations. So there's no progress without energy. So we have to think of initiatives, drives, which will give us solutions. So I'll just change gear and then take you to an experience, a national initiative in which I was very fortunate to be associated with for years. I don't know how many of you would have heard. Those of you who are from academia, you would have definitely heard this. In 2015, 2010, first let me see, no, that slide is not here. 2010, United States declared to the rest of the world something called grand challenges. So they identified 14 specific questions. For example, make solar energy affordable. Find better ways of fixing nitrogen and carbon dioxide. And so on and so on. Very specific targets. And India was invited to be a part of those grand challenge initiatives. So I had the privilege of taking a delegation of Indian National Academy of Engineering to the US. We discussed, we came back, and the then Human Resource Minister, Mrs. Smriti Irani, invited all IIT directors for a retreat in Goa and asked all of us that please suggest something different that you would like to do, which is going to make a huge difference to the nation. So a lot of good ideas came out of that deliberation, 2-3 days of deliberations, and one of them was this, which eventually culminated next year, 2015, and what we said that India must not follow the developed nations because their basic reference point is at a much higher level. Before we think of making solar energy affordable and think of the specific devices, we first have to look at the grid, look at the locations, look at the supply of the solar cells, their encapsulation, deployment, and so on. So multiple things involved. So we discussed, and then the ministry agreed to launch this program. Why I'm showing this slide to you is to kind of impress upon you as the honest effort of the government. I don't think you can ever recall, neither can I, that a scientific initiative of the country was launched from the Darbar Hall of Rashtrapati Bhavan, where the ministries take oath, and was launched by the topmost political leadership of the country, the Prime Minister and the President. And what was this about? 10 domains, not civil engineering or mechanical engineering, but domains chosen as domains related to the living world, domain related to the materials world. So healthcare technology. Now, whichever way you solve the healthcare issues, whether it is through doctors or engineers or a combination of them or with electrical devices or mechanical devices. For healthcare technology, what needs to be done? Likewise, for sustainable habitat, for energy security, for water and river systems, and so on and so forth. So 10 domains, each had 10 themes, and each of these 10 themes had about 100 variants. So altogether, 10 raised to 5. And we eventually, we explained to the Prime Minister that, so there are million problems that this country must solve, and the reassuring factor is that we have 1 billion to take care of them. And the Prime Minister told in the launch that, science can be universal. The know why component is universal. What you solve here is not going to differ what you have in another place of the world. But engineering solutions must address local issues. So nobody is going to solve your transportation problem, your habitat problem, and so on. But when you pursue science, then obviously what you come out with will be useful to the rest of the world. So this was launched in November 2015, and within 4 years, we had an exhibition at IIT Delhi, which we called Tech Exhibition or TechX. 80 models were showcased, working models. So in this imprint initiative, all IITs, all NITs, all education institutions participated, and even industry was invited. It's a long story. All I want to say is that I want to show you certain examples of handheld device for HB1C determination. It's a very difficult, tedious process. You have to go through hours of titration and so on. So this was just like a drop of blood, and then immediately you come out with the HB1C value. Similarly, there was another on blood control, blood parameters, on microfluidic devices which is basically a point of care for glucose detection or hemoglobin detection. There was something else on. So basically, there were 80 such prototypes showcased. They are not commercial products. Some of them eventually hit the market as commercial products. So Imprint was an important initiative whereby academia, members of the academia could prove that within about 3-4 years, they could demonstrate certain translation of fundamental knowledge into viable prototypes, not sellable technology, but prototypes. This is exactly what we need today, that whatever research we do, whatever knowledge we generate, has to have a certain application, certain utility. I don't think I'm doing well in terms of time. I wanted to just give you one or two examples which you may... so I had the privilege of serving an institution in Calcutta called Glass and Ceramic Research Institute, an institution which celebrated its 75th year, is celebrating in this current year, an institution which was established with the vision of legendary scientist Meghnad Saha, who, borrowing from the Second World War experience, understood that India would require a lot of applications with lenses for cameras, for telescopes, for various optical devices, lasers, and so on. So he created, this is the 4th oldest among the CSIR chain, situated in Calcutta. And there's a very nice history why this was founded in Calcutta. You would have heard of those who are from that part of the country, Krishna Glass Factory or many other glass factories. Calcutta, particularly South Calcutta, used to have one point of time very many glass factories, all because of this became a hub. And primarily that's because very good supply of silica, the main ingredient, and plentiful supply of good quality coal. By 70s, when natural gas was invented in the western coast of the country, the entire industry shifted to the west. So today you find practically no glass or ceramic industry in the eastern part of the country. Anyway, so CGCRI developed this particular glass called radiation shielding window glass, which is used in nuclear reactors, and is an import substitution. Took 4 decades for CGCRI to develop and perfect the technology. Now, the customers are very few. Customers are very few. Only very specific atomic energy need that, because when you do nuclear fission, you emit alpha ray, beta ray, gamma ray. Out of all these, the gamma ray is the most harmful because it's most penetrating, the shortest wavelength, the most penetrating. In order to stop that, you actually need very thick shields, but at the same time, the operator, while working on remotely, should be able to see that you are picking up uranium, you're making a pellet, you are charging, and so on. Otherwise, you cannot be 100% sure. And somewhere in the middle, if something goes wrong, you can't open the door, go inside, and then fix and come back. So it has to be sealed forever. So this window is very crucial. And all of us are aware that, for example, mirror, when you buy a mirror, over a period of time, the mirror degrades. And the quality of image that you develop gets distorted. That's because the refractive index changes with time, and certain defects develop with time. So the window cannot be changed. So for that reason, this has to be without. But then this window, why am I talking about this? Because this project, if the project cost was 100 crore, 75 crore of that was necessary to buy only one very major implement of that project, not the main product, not the raw material. Only one very important component necessary to run the project, and that was pure platinum. Why pure platinum? Because when you melt silica, you don't need to take much of a protection. When you melt lead with silica, lead oxide with silica, it becomes so highly corrosive, it can penetrate any amount of refractories. Normally, when you have refractory, those who are from steel industry, you would very well know that if you have alumina or silica refractory, you can very well melt steel, but not lead glass, because it has such corrosive ions which can penetrate and puncture. The only thing which actually can contain the melt is a platinum shield, is a platinum sheet. So there's a long story as to when platinum used to get transported from Maharashtra. Army used to give protection to that vehicle all along the route. Why CSIR spent 4 decades to develop this technology? Because there were only 3 countries in the world, Russia, US, and Germany, who could develop that. Now, if India wanted to pursue nuclear energy as a viable, I told you the importance of energy, and even today India is not just one of the 8 nations who can harness nuclear energy. We are now hearing a lot about SMR, the small modular reactors, and these are nuclear reactors. So basically, if you want to pursue nuclear energy, you need reactor, you need chambers, protected chambers, and you need radiation shielding window glass. And if you depend perpetually on some other nation, any day they can pull the plug and say that we are not going to supply. So then you are completely stalled, halted. So this is what is known as technological self-reliance, right? But it doesn't happen just at the drop of a hat. It took 4 decades. By Professor Dr. Atmaram started in 60s, in 70s, and by the time I joined, we were able to supply the last consignment of few tens of tons of radiation window glass. So there are many other examples which takes decades. This laboratory developed, we all use optical fibers for communication. There's the only laboratory in the country which actually starts from preform of the order of, say, 10 centimeter. Imagine you have a 10 centimeter preform, sort of a cylinder, and from there you draw fiber which is 10 micrometer. So 5 orders of magnitude of reduction. So from 10 centimeter to 10 micrometer. And so it's like your hair. And that 10 micrometer is actually not a single wire. It has a concentric core which has a much higher refractive index. So that when you launch light from here, it won't dissipate in another end because of the in total internal reflection within this high refractive core. So CGCR had developed several of them, and actually it got translated. We won a number of national awards or something. But then technology is not always very difficult to develop, you know. There was one example I can tell you that in Gujarat, Morvi, where we had a lab, and they were able to demonstrate that we use tiles. Everywhere we see tiles, big tiles today. If you recall, 10, 15 years ago, the maximum size of the tile used to be 2 feet by 2 feet. Today it is meter by meter, in some cases even more. Now, the quality of the tiles used to be good only when majority of them were all imported. And the imported tile would use something called Ukrainian clay. It actually used to come from Ukraine. And our scientists there, actually technicians, not even scientists, they were able to show the local clay when they could leach out the iron oxide part of it by acid leaching. Then that clay, when fired, gives you exactly the milky white color. When iron oxide is present, it forms a low melting eutectic and gives a reddish tinge. When you remove iron oxide, then you get rid of that tinge. So simple improvisation or innovation, because of which there used to be hardly about 20, 30 units, and it becomes several hundred units overnight, very soon. Each of them making an additional profit of several crores per year. So imagine what is the impact on the economy. And you all are aware that Gujarat, in one single district, you have the largest concentration of course, they are notorious for polluting the environment, but the fact remains that these kind of interventions can make such a huge difference to the economy. So as engineers, I think this is exactly what we should try to aim on. I'll come to this point. This is the important point that I was referring to all along. What is plotted here is Human Development Index as y-axis and per capita power consumption as x-axis. So y is a function of x. And so how much energy you are consuming and where do you stand in terms of Human Development Index. So if you just see this pointer, India is somewhere slightly better now, 0.66 or something, but we have a long way to go. And we have a long way to go, and we can go higher up. So if you go way above, that's not possible. You cannot increase your standard of living without consuming more power. Today, 20 years ago, how many of us used to live in air-conditioned houses? How many of us 50 years ago could imagine having a geyser in our toilets? Today, the lifestyle has changed for the better, but there's a price we are paying. The electricity consumption has gone up, yet it is 1/3 of the world average. So if we want to compare ourselves to be comparable to the rest of the world, then we have to move not only along y-axis, automatically we'll also have to move along x-axis. And then only we should be in the likes of Norway, US, and so on. So that's exactly the problem definition. There are many other things that one actually needs to talk about in terms of the outlay in, which I mentioned, the outlay in education. How much money we spend per researcher in the country. This is way too low compared to the developed nations like United States, Germany, or Austria, Italy, and so on and so forth. Only 14% of the population in the country between the age group of 25 and 65, employable age, right? Anybody can seek an employment. Typically, you expect between 25 and 65. Only 14% of that population today carry a degree, carry at least one degree. And compared to countries like Switzerland or, Finland has a population 1/4 of Calcutta. Finland's Global Innovation Index is 7th in the world, and we are 38th in the world. Now, this doesn't happen just by wishing that, if we just wish that tomorrow we should be seen as a developed nation, it won't happen. It will only remain a dream. So there's a lot of hard work that we need to do before we actually can go there. I just want to make, before I end, I wanted to make one mention to it, that today this is a very new challenge that we are seeing. Before I say why we must embrace artificial intelligence, I would give you 3-4 examples. Kodak went bankrupt because Kodak did not realize the world is changing from plates, the films, to digital photography. 50 years ago, when I was a child, we all knew that cameras and films and so on, the whole world was run by, in the photography, Kodak, Oro, and all those big companies. They're all wiped out today, right? IBM, Xerox, failed to realize that mainframe computers will have to give way to personal computers. And today, you don't need even personal computers. You do many things using your own cell phone. So these are the changes that happen, and if you don't embrace, then you are left out. And you are not only left out, you are rendered redundant. Nobody needs you anymore. So it is for this reason we must realize that artificial intelligence is not something that is going to come or is seen in the horizon. It already is affecting each one of us, be it in industry, be it in personal life, be it in creativity, in sports, in music, in decision making, in politics, everywhere. But the biggest there are multiple issues. I don't want to spend a whole lot of time. I've already consumed enough. The challenge, is not if you don't know how to use it, and if you don't know how to train yourself, like the cell phone example I gave you, we all carry a good cell phone, a very fantastic device. Probably it has capacity for doing 100 jobs. We know only 10 of them. So even if I have money to buy a very good implement, I'm not even capable of making use of them. The same way, all the machines tomorrow will be powered by AI tools, and if I don't know how to make use of that, I'll be left out. Anyway, so I'll come to the end, just drawing your attention to a few of the, you don't have to give me a warning. I should have given you a warning before, the way you lost some precious 1 hour for me. In my opinion, science is pursuing the truth relentlessly, regardless of its necessity or immediate application. Science is universal. Engineering is for providing solutions, borrowing from science. Technology is the last mile for societal benefit, based on scientific discovery and engineering inventions and innovations. If India has one unique resource and strength that the entire world envies, that certainly is the demographic dividend. The largest and the youngest population. How do you empower them? So if you really have that level of education, training, then only we can aspire to be a developed nation. So I would just end here thanking you all, and I would like to remind you that as engineers, we certainly can make a huge difference to the society, provided we know the coordinates well, who we are, where we derive our strength, what is our purpose, and the deliverables that we should aim at, and how we can deliver without endangering the environment and the society. Solution, engineering is all about providing solution and answer to the human aspirations, but it has to be sustainable. It cannot be at the cost of somebody else. Thank you very much. Jai Hind.
We sincerely thank Professor Manna for such an insightful and quite an engaging lecture. We are thankful to our speaker of the 34th Dr. Amitabh Bhattacharya Memorial Lecture. I shall now request Engineer V.B. Singh Sir, President of IAI, and we request him to very kindly felicitate our speaker of the 34th Dr. Amitabh Bhattacharya Memorial Lecture. I request the team member of the organizing committee to help Engineer V.B. Singh sir and Major General Dr. M.J. Sali sir in felicitating our esteemed speaker. We are extremely honored that Professor Indranil Manna, VC of BIT Mesra Ranchi, spoke here in this great hall. And I shall now request Major General Dr. M.J. Sali sir to formally thank Professor Indranil Manna for this lecture.
Engineer V.B. Singh, President IAI, Professor Indranil Manna, distinguished council members, delegates, guests, ladies and gentlemen, it's my proud privilege to propose a vote of thanks to our distinguished speaker, Professor Indranil Manna, who has graciously delivered an inspiring lecture on science, engineering, technology, synergy needed for Atmanirbhar Bharat. In his address, Professor Manna eloquently traced the continuum from science to know-why to engineering as know-how and technology to know what sells, highlighting how these pillars must converge to translate knowledge into societal progress. He reflected on India's rich civilizational legacy, its demographic strength and aspirations of a young nation striving for education, equity, growth and self-reliance, all of which call for deeper integration of scientific inquiry, engineering innovation and technological leadership. He also showed several examples of how such critical technologies have been developed in the nation, which were quite a knowledge for all of us. We are deeply grateful to him for taking time out of his busy schedule to share such profound insights and for enriching us with a thought-provoking discourse. I now propose all present here to join me in offering a big round of applause to Professor Indranil Manna for his contribution.
Thank you, sir. We once again sincerely thank Professor Indranil Manna. And now we are again honored to invite to the dais our speaker of the 38th Dr. A.N. Khosla Memorial Lecture, Professor Taposh Chakraborty, VC of Macau. Sir, please, we are honored. I shall also invite to the stage the speaker of 15th Professor C.S. Jha Memorial Lecture, Mr. Praveen Kumar, MD of DFCCIL. I sincerely request our speaker for the 47th Sir R.N. Mukherjee Memorial Lecture, Mr. Akhil Gupta, CEO and Executive Director of Shapurji Pallonji Engineering and Construction. We are sincerely honored to have on stage Professor Indranil Manna, and we are also honored to invite to the dais Professor Taposh Chakraborty, VC of Macau, Mr. Praveen Kumar, MD of DFCCIL, and we also invite to the dais Mr. Akhil Gupta, CEO and ED of Shapurji Pallonji Engineering and Construction. আমাদের টিমের মধ্যে থেকে একজন এসে স্যারকে একটু হেল্প করতে হবে ল্যাপটপটা কানেক্ট করানোর জন্য। Ladies and gentlemen, we are now going to move to the 38th Dr. Ajodhya Nath Khosla Memorial Lecture organized by the Institution of Engineers India. This memorial lecture has been instituted to perpetuate the memory of Dr. A.N. Khosla, one of the most eminent engineer administrators of our country, and a former president of IEI. Widely regarded as the father of river valley projects in India, Dr. Khosla's pioneering work laid the foundation for several landmark national infrastructure projects. And our speaker of this memorial lecture is Professor Taposh Chakraborty, Vice Chancellor of Maulana Abul Kalam Azad University of Technology, Macau. I request Engineer V.B. Singh, President of the Institution of Engineers India, to kindly present a bouquet of flowers to the memorial lecture speaker, Professor Taposh Chakraborty, a floral presentation to warmly welcome him onto the dais. Ladies and gentlemen, we are quite regretfully request our great speakers to kindly allot 30 minutes to their lectures
No, it's not coming.
due to the paucity of time.
Do you have any pen drive or anything? Or do you have your own computer?
I sincerely request Mr. Praveen Kumar, MD of DFCCIL, to also kindly grace the stage.
Can you call them?
And I shall also request Mr. Akhil Gupta, CEO and Executive Director of Shapurji Palonji Engineering and Construction, to very kindly step on the dais. Ladies and gentlemen, we are now going to hear directly from Professor Taposh Chakraborty, Vice Chancellor of Maulana Abul Kalam Azad University of Technology.
This one, right? Okay, I think this is going to work. Fine. I can just stand here and speak, right? Okay. Sure.
Madam, Professor Chakraborty একটু ইন্ট্রোডাকশনটা স্যালিসের চাইছি একটু দেখিয়ে দিন না ম্যাডাম
I shall now recount the background of the lecture. Dr. A.N. Khosla Memorial Lecture was instituted to perpetuate the memory of Dr. Ajudanath Khosla, a distinguished engineer cum administrator of the country, and was first delivered at the Second Indian Engineering Congress held in 1988. Having graduated from the Dayanand Anglo-Vedic College, Lahore in 1912, Dr. Khosla's first major assignment was the survey and investigation connected with Bakra Dam project. The dam had been built on the very access line that he marked in 1917. His important contribution to engineering was the invention of Khosla disc for precision leveling across rivers and wide valleys. Dr. Khosla also led the Indian delegation to the United Nations for the Indus water dispute with Pakistan. Due to his monumental contribution to the water sector in the country, Dr. Khosla is also called the father of the river valley projects in India. Dr. Khosla was the president of the institution during 1948-49 and 49-50. He was a member of Rajya Sabha during 58 to 59 and member of the Planning Commission in 1959. He was appointed the governor of Odisha in 1962. About the speaker, it's my proud privilege to introduce our distinguished speaker for this prestigious memorial lecture, Professor Taposh Chakraborty, PhD, Vice Chancellor of the Maulana Abul Kalam Azad University of Technology in brief, Makaut, West Bengal. Professor Chakraborty is an eminent scientist and academic leader whose career spans premier institutions such as IIT Kanpur and Indian Association for the Cultivation of Science. He served as director of IACS from 21 to 23, 2021 to 2023, and as a senior professor there for over 16 years, following a notable faculty tenure at IIT Kanpur. A leading researcher in laser spectroscopy, mass spectrometry, and atmospheric science, he has published 125 research papers in top international journals and supervised 22 PhD scholars. His contributions have earned him numerous honors, including fellowships of the Indian Academy of Sciences, Indian Chemical Society, and the West Bengal Academy of Science and Technology, along with prestigious recognitions such as INSA Young Scientist Medal, J.C. Ghosh Memorial Lecture Award, and multiple Ramanna Fellowships from the Department of Science and Technology. His international academic engagements include positions at Aarhus University and Technical University of Munich. He also serves as Associate Editor of the Journal of Chemical Sciences. With these words, I have great pleasure in inviting Professor Tapas Chakrabarty to kindly deliver the memorial lecture.
So thank you very much for kind introduction. Being a Vice Chancellor of the university, as many of you are, possibly served in different capacities, that we all know that most of the times you are away from whatever science and engineering things that we do. We need to do mostly paperwork. Whenever I get chance, and whatever be the nature of the audience, I usually try to talk about the science and this little bit engineering that we do. I started my career at IIT Kanpur, and my passion was to build small apparatus. I do that with my students. And a kind of small apparatus that we recently did, of course, we got a patent. That is a different issue, all these things. But I thought that in this 40th Indian Engineering Congress, where this average age of the audience is likely to be of my age, that is around 60, at that age, hardly we like to say anything difficult, hardly we understand anything difficult. We always try to say something superficial on the word to things. So what I will do today, something very simple. That is, I built a small apparatus recently. And what is the utility of this apparatus? That I am going to talk today in this engineering congress. Now, what is this apparatus about? This is about measurement of a small trace gas, a very important trace gas in our atmosphere. Why atmosphere is important? Because whatever engineering technology we do, we need to interact with our atmosphere. Usually we say that because of our civilization, we usually try to impact our environment, our atmosphere with the pollution. And what the common pollutions are that we always see in the newspapers, because every day we just open the newspaper, we see about the pathetic situation of the atmosphere of Delhi and also some of the major cities. And we know what the components are. But today, my whole objective is to tell you that some of the common pollutants which are released from our industries, which are essential even for our survival. So that is the kind of message that we would like to convey in today's 30 minutes lecture. Now, what is called this trace species? When we can say that either in water or in our air, a species is called trace. Now, trace species that I have defined it here, a species is of the concentration of, if it is about part per billion or about part per trillion. Part per billion means that one part of out of 10 to the power 9, that is billion, or part per trillion means that one part out of 10 to the power 12. So if in our atmosphere or in the water, if the species is of this little concentration, then we say that this is a trace species. For example, in the month of December 2025, in the Durgapur, which is supposed to be an industrial city, if you see that this common emissions, like carbon monoxide, this is about 686 to 806 part per billion type. And what I have denoted here with this red color, this is the WHO approved tolerance limit. So you see that this is a much below compared to this. On the other hand, NOx means that's nitric oxide and nitrogen dioxide. Both are produced as the emission of our automobile vehicles or from this thermal power plant. And this concentration is about 21 to 23 part per billion. And this is nearly double compared to this WHO approved limit. Similarly, this ozone, O3, this is again almost this 1/3 of this WHO approved limit. Now the question is the following, simple question, high school chemistry. We all know that a very large amount of carbon monoxide for our activities, carbon monoxide means that when the carbon is not fully burnt, partially burnt, that is released in the atmosphere. So if every day, if the large amount of carbon monoxide is released in the atmosphere, then how we are surviving? Because carbon monoxide is a poisonous gas. So it means that our environment has its own mechanism, like our body system. Our atmosphere is also a living entity. It has its own internal corrective mechanism. And because of this internal corrective mechanism, the carbon monoxide is actually removed from our atmosphere. So what this corrective mechanism is? Now this is a very basic chemistry, but to understand this basic chemistry, what you usually require is a very sophisticated science and technology. And most of the cases, these things are not done in our country. We just depend on other countries. Anyway, so these are the things that commonly we know. Like suppose as an example, I have given here this ozone. Ozone means that we have the common idea, because we talk about also this to our students, that there is an ozone hole because of this CFC. So CFC has been banned, and some alternative has come out in the market as this refrigerant. Why CFC is banned? What is the problem with the CFC? Because when CFC is released, then our atmosphere, it does not have any mechanism to remove it. So with time, it basically propagates to this upper atmosphere, where these ozones are there, and it's a complicated reactions of this ultraviolet light of the sun and the CFC and the ozone. It basically affects this ozone. I'm not going to that direction. Now see here, that if you look at this, the ozone, if you try to plot it as a function of this altitude, you see that this ozone concentration is maximum about this 22 kilometer above this earth level, and this is called this ozone layer. And scientifically, it is called this good ozone. But at the same time, if you look at our troposphere, that is at the earth level, there is a little height here. So this is called this bad ozone. Bad ozone in the sense that this ozone is responsible for this Delhi's pollution, and also for this pollution of any of these major cities. And it is responsible for all kind of these pulmonary diseases that we have in our this breathing system. Now the question is that, what is the source of this ozone? How it is produced because of our these anthropogenic activities. Anthropogenic activities means that industrial activities, and why this is also required for the sustenance of the life on the atmosphere, this on the planet. Now here I have given a brief outline. You see that it's a very basic chemistry. All of us know this chemistry from the high school level. We talk about this nitrogen dioxide as it is a pollutant. But this nitrogen dioxide, what I have shown here, from the sunlight, this ultraviolet light that is reached on our atmosphere. This blue region means that these are the different wavelengths of the light that is reached on the earth level. And when this nitrogen dioxide absorbs this sunlight, ultraviolet light, it breaks into two components. One is called this nitric oxide, and another is called this atomic oxygen. This atomic oxygen combines with the molecular oxygen that is present in our atmosphere and produce this ozone. So it means this ozone production is because of the production of this nitrogen dioxide, and nitrogen dioxide is basically a pollutant from this vehicle and also from all kind of this thermal power plant. Okay. Now once this ozone is produced, so it means that ozone is in that way, it is eventually an industrial pollutant, although ozone is not released directly into our atmosphere. Okay. But this nitric oxide, it can combine with this ozone that is produced and converted again to this nitrogen dioxide. So through this cycle, this ozone that is produced, which is harmful, is again removed. So in that way, what I am trying to say that our atmosphere, it is a basically living system, living in the sense that it makes its own correction through this kind of a reaction cycle. Now you see that for this, what is essential is the sunlight. Without sunlight, this ozone cannot be produced. Without sunlight, this cycle can also not be complete. So sunlight is not only responsible for this photosynthesis that gives our food, but it is also gives a corrective mechanism to make the corrections of our own atmosphere. Now I'd like to tell you something miracle in the sense that this information was discovered only a few decades ago. We talk about carbon monoxide. Let me tell you, this is a very take-home message. In our atmosphere, there is no reaction, there is no other mechanism that can remove carbon monoxide. Because if you mix carbon monoxide with the oxygen, keep it in a cylinder over months or year, there will be no reaction. Then the question is that so much carbon monoxide is released in our atmosphere. What is the mechanism for the removal of this carbon monoxide? So here is this. We always talk about the detergent that is used for the cleaning of our clothes. But the atmosphere has its own detergent. So this detergent, it is called this OH radical and hydroperoxide radicals. Okay? This is detergent. Detergent in what sense? Because this hydroperoxide, this is called this hydroxyl radical, this is the most powerful oxidizing species that our nature has produced. Most powerful oxidizing species. Any molecule, any kind of pollutant that has a hydrogen atom, it can react and immediately abstract a hydrogen atom. And it makes it reactive. Now the question is that how much hydroxyl radical is present? You see that per liter its concentration is about 10 to the power 9. Let me give you a comparison. If you are from industries, we always talk about this molar level of concentration. Molar concentration means that when you have this about Avogadro number, it is called 10 to the power 23 molecules per liter. Compared to that, this radical, that is what is called this atmosphere's detergent, is only 10 to the power 9. Question is there any technology that can measure this concentration? You see, if you compare these things with 10 to the power 23, it is about 10 to the power 14 order of magnitude smaller species. Then how do we know that this species is present? At present, we don't have any handheld technology that is available in the market that can measure this concentration. Only we need to do it indirectly. Now, because of this presence of this hydroxyl radical, we are surviving. Because atmosphere, it's a basically big reactor. And the reaction that is happening is the oxidation reaction. And only species that is responsible for this oxidizing species is this radical. Okay. So this is the message that I wanted to tell you. And this discovery, it was done only just 20 to 30 years ago. And now the point is how it is responsible, how it is saving us. Because this is the only mechanism that is known in our atmosphere. This hydroxyl radical can react with carbon monoxide and it is converted to carbon dioxide and produce this hydrogen atom. And this is the only mechanism by which this poisonous carbon monoxide that is released from our atmosphere. There is no other mechanism. It is the only mechanism. Okay? Then the question is that what are the source of this hydroxyl radical? How it is produced? So that is that is what I wanted to contribute a little bit. Now, if we always talk about this methane, methane is produced from the in our agricultural field and also from this cattle industries. And only mechanism that is known for the removal of methane in our atmosphere is this reaction. Hydroxyl radical abstract a hydrogen atom from methane and produce a water and this methyl radical. There is no other mechanism. So this is how methane is removed from our atmosphere, okay, to keep the life survived on the earth. Okay, now coming back, how this hydroxyl radical is produced. We talked about this ozone. We always say that this ozone is a very highly pollutant species, pollution. But you see that ozone is responsible for the creation or production of this hydroxyl radical. How? Ozone absorbs ultraviolet light of the sun that is present on the Earth atmosphere. This little component that is present, because most of the things are absorbed by this ozone layer. So this atmospheric ozone that is present at this ground level, it absorbs ultraviolet light, and again it breaks and produces this oxygen atom. This oxygen atom reacts with this water vapor that is present in our atmosphere, and that produces this hydroxyl radical. So this is the corrective mechanism. How much? This path, it produces about 40% of the hydroxyl radical that is required to keep us survived by removing carbon monoxide and methane. What about the rest of the part? Another 40%. The rest of the part, I am going to just tell you here, this is the last that gives us the channel for the production of this OH radical. This molecule, it is called this nitrous acid. We always talk about nitric acid. Similarly, we also know that nitrous acid. Nitrous acid, this is also a small atmospheric pollutant. But at the same time, it is responsible for our survival. How? This nitrous acid, it absorbs ultraviolet light of the sun that is present in the Earth's level and then dissociates and produces this OH radical. So my research, what I tried to do starting from this IIT Kanpur, that can we measure this nitrous acid, how much it is present in our atmosphere. And at Calcutta, at this Indian Association for the Cultivation of Science, this is the first time that in the South Asian countries we measured this, what is this atmospheric abundance of nitrous acid in India, particularly in the Southeast East Asia. Data are available from most of the advanced countries, but in our atmosphere we did it for the first time. Typical abundance is this much, about 0.2 to about 2.5 part per billion. I just tried to repeat this part once again. This is a very important atmospheric reaction. Because of this photochemical reaction, this OH radical that is produced, and this is responsible for the 40% of maintaining the oxidizing capacity of our atmosphere. The research that we undertook is that what is the natural abundance of this nitrous acid in our atmosphere, Indian atmosphere. This is what we did. Now, why do you need to know these things? Because billions of dollars are spent by USA and these other advanced countries to get this information, because this information, unless we know that, it basically affects our vegetation. And also to devise the policies that how to regulate for this emission of carbon monoxide, carbon dioxide, nitrous acids, and all this other kind of these oxides. And because of this BS1, BS2 to BS6, all this kind of, this regulatory issues came. There are several mechanisms by which this in atmosphere nitrous acid is produced. I am not going to details about these things. Only thing is that a small device that we made, I am going to talk about it. Now the device is that it is based on this kind of principle. That that in industry, whether it is biochemical industry or any other industries, that this light absorption, it plays a very important role to measure the concentration of this species. And this concentration is a very simple thing. It's like this. If you take any kind of species, whether it's a biochemical species or normal chemical, and pass light through it, then what happens that because of this light absorption, light intensity is dropped, and it follows a simple law here. It is called this Beers-Lambert law. It is taught in all undergraduate level courses. And because of that Beers-Lambert law, we know usually that what is the concentration of this species. Now to measure a concentration of the level of fraction of part per billion, that is not an easy job. It's a very difficult job. Now that we have achieved by devising a small technology. So this technology is a kind of actually your that what it is shown here. It is a kind of optical fiber. We all know what optical fiber is, but this optical fiber is a basically liquid filled optical fiber. It is made of plastic. Plastic means is a very special type of Teflon tube. You see that as this outline I have shown here. This small type of technical tube, if you fill it with the water, then immediately it starts behaving as an optical fiber. A water-filled Teflon tube behaves as an optical fiber. What is the basic mechanism of this optical fiber? Because if you try to pass light through it, then we know that because of this what is called this total internal reflection. At the high school level physics, we all know that total internal reflection occurs that when the light is transmitted from a medium of this higher density to this kind of lower density, and this density is measured here in terms of this your refractive index. Now you see here, this material, the refractive index is about 1.33 for about 1.29, and water refractive index is about 1.33. So if you try to fill up these things with the water, then if you try to pass light through it, then since the refractive index of water is larger compared to the refractive index of this material, then because of this multiple internal reflection, you can pass light through this tube and it can behave like an optical fiber. How it can be helpful to measure the trace species? Because we have seen that, we have estimated in our laboratory that if you take a tube, optical fiber, about 1 meter long and filled up with this water, then effectively because of this internal reflection, multiple type of reflection, the effective path length, that is the length that a light travels, is nearly about 1 kilometer. So this 1 kilometer to about 1 kilometer, 1 meter to about 1 kilometer, so this advantage that you get once you have this liquid filled waveguide. Waveguide means here this light is an electromagnetic wave, so in that way it is a waveguide. Very recently we saw that this material, it has been commercialized by some of this American company. Although we got patent, but I tried to sell these things to some of our industries, they did not like to take it. They said that no sir, actually not many takers are here. Yeah, it will not be a good business, but anyway, it has been very helpful to measure at least to take it to the field. And how we did that? Because we wanted to measure this nitrous acid, how much it is present in our atmosphere. By some simple chemical modification, we convert it into a dye. I am not showing this chemistry here. This is how this dye from this nitrous acid that is produced is the light absorption characteristics. Now here I will not continue more. Here it shows that to what extent concentration that we can measure. See, we have calibrated in our laboratory, and this laboratory calibration we see that we can measure the concentration of the order of about several tens of part per trillion. Part per trillion. So this level of sensitivity that we have been able to achieve in our laboratory. This is the basics of this apparatus that we have built. It is based on again a kind of these lasers. Lasers are required, so-called optical fibers are required, and of course other electronics are also required to process the signals. I am not getting into details of these things. Only thing that everything that I wanted to say is the end result. We have been able to measure concentration of the level of part per trillion in the atmospheric species. It is not necessary that it has to be only atmospheric species. Any kind of biochemical materials, trace amount, whether it is present as a contamination in the tea or any kind of food, that also can be measured. And here is where this particular this geographic location that where we measured it. And finally, just I would like to show you here that this is actually the diurnal variation, that with time, how it actually varies with time. So this is this HONO, that is nitrous acid atmospheric concentration. You see that this is a kind of this wave. Wave means that it is a day, about 2 weeks time that we measured. So starting from early morning to next early morning, in 24-hour cycle, how in our atmosphere this concentration varies, that we are able to measure, and how this concentration is related to some other species like nitrogen dioxide, ozone, and kind of this your other particulate matter, that is whether it is 2.5 or 10, and relative humidity, that also we tried to measure. And this is of course saying that in a particular day in our atmosphere, how this concentration is varies, starting from the early morning to midnight. And here actually I tried to say here that this is what we measured in Calcutta in India, and compared to that what the other part of the different world, that concentration has been measured, and it is not very different compared to what we have here and the rest of the part of the world. And finally I would like to say is that this hydroxyl radical and this nitrous acid, or this HON, or this atmospheric nitrous acid, it's a very important species, because much of the scientific paper that comes out, so-called this high impact journal like Science, Nature, PNAS, lot of articles are on this particular species, because it is responsible as an atmospheric pollutant as well as for our survivability. That's what I'm trying to say you. And with this I just stop here. I hope that I have been able to finish in a shorter time. And to summarily, I wanted to tell you a small apparatus that I have been able to build in our laboratory, and I find it is a fun in addition to the Vice Chancellor's job in the universities. Now, I did not like to tell you here about our university, but to say very briefly, this is although called this Maulana Abul Kalam Azad University of Technology, but this earlier name was West Bengal University of Technology. Like every state has a technology university. The whole idea is that all the colleges, like our engineering colleges, management colleges, pharmaceutical colleges, our university gives the degree. In addition to that, we have our in-house program. Our main academic campus is at the Horinghata in West Bengal, in the district of Nadia. And in addition to that, Calcutta also, that we have one office, that where we have this inspection department and also this examination departments. So under my university, there are about 200 colleges, and we have some of these very unique technology. We have been able to devise, and that is actually in use as far as the examination system is concerned, because in my university, the question paper making is completely automated. Automated in the sense that for every subject we have a question bank, and we have developed a kind of program that at the different level that questions are made from this question bank without any human interference. Only thing is that we need to specify a different level of questions, like 2-mark questions, 5-mark questions, 10-mark questions, and so on. And then, of course, moderation part, that the human interference is there, because eventually what technology has produced, finally it needs to be checked. And then after examination, quickly all the answer papers are brought to our Calcutta office. Those are digitized, and the examiners look at only on their computer the digital copy. And so that they can make this evaluation also on the computer screen. They need to only put the numbers, and this addition, grading, those parts are also automated. So that is how that we run in our university. In our main campus, our main activity, academic activities, are in the area of computer science, IT, biotechnology, and management. But in addition to that also, that we have other subjects that we teach our university. So that's all about it. And thank you very much for listening me. And I also give the organizers, I'm grateful that they gave me a chance to talk about a little bit technology science that we are doing in our laboratory. Thank you very much.
Ladies and gentlemen, we sincerely thank Professor Taposh Chakraborty, Vice Chancellor of MACAUT, who was the speaker of the 38th Dr. A.N. Khosla Memorial Lecture. We sincerely request Engineer V.B. Singh sir to felicitate our esteemed speaker, Professor Tapush Chakraborty. Ladies and gentlemen, I shall now request Major General Dr. N.J. Sally sir to formally thank him.
Engineer V.B. Singh, President IAI, Professor Tapas Chakrabarty, distinguished delegate, council members, guests, ladies and gentlemen, it's my privilege to propose a vote of thanks to our distinguished speaker, Professor Tapas Chakrabarty, who has honored us by delivering an enlightening lecture on a laser-assisted long-path liquid core optical guide apparatus for environmental monitoring of trace species. In his address, Professor Chakrabarty presented a pioneering optical innovation capable of detecting chemical species at parts per trillion levels using total internal reflection and laser-assisted sensing to achieve unprecedented sensitivity. He explained the design of LLOG reactor detector system, its instantaneous and interference-free quantification, and its demonstrated applications in measuring atmospheric nitrous acid, blood urea nitrogen, and aqueous sulfide ions, an invention that has culminated in a patent granted in 2024. We are sincerely grateful to Professor Chakrabarty for sharing his time, expertise, and remarkable scientific contributions with us today. His insights have enriched our understanding and offered a glimpse into the cutting-edge environmental monitoring technologies. May I now request all present here to join me in giving Professor Chakrabarty a big round of applause for his thoughtful and inspiring contribution.
Thank you, sir. Ladies and gentlemen, we now proceed to another distinguished memorial event of the 40th Indian Engineering Congress. The 15th Professor C.S. Jha Memorial Lecture, organized by the Institution of Engineers, India. This memorial lecture was instituted in memory of late Professor C.S. Jha, an eminent electrical engineer, distinguished academician, and outstanding institution builder who served as director of IIT Kharagpur and vice-chancellor of the Banaras Hindu University. The 15th Professor C.S. Jha Memorial Lecture will be delivered by Mr. Praveen Kumar, IRSC Managing Director of Dedicated Freight Corridor Corporation of India Limited. Mr. Kumar is a senior engineering leader with vast experience in the planning, execution, and management of large-scale rail and logistics infrastructure projects that are critical to India's economic growth. I now request Engineer V.B. Singh sir, President of the Institution of Engineers, to kindly present a bouquet of flowers to our eminent speaker, Mr. Praveen Kumar sir. Ladies and gentlemen, I shall now request Engineer V.B. Singh, President of the Institution of Engineers, to kindly address the audience and warmly welcome Mr. Praveen Kumar sir amongst us here.
Please give help. Surajit.
लगाना पड़ेगा ना लगा दिया सर माइक ठीक है सर प्रेजेंट ये वीडियो इधर है हाँ और ये प्रेजेंटेशन है जो पहले वीडियो कहाँ है ये है वीडियो क्लिक करना इसको क्लिक कर दो ऑन कर दो ऑन कर दो फिर स्टॉप कर देंगे
मेरे को थोड़ा आपको इंट्रोड्यूस करना पड़ेगा
हाँ हाँ करिए
आप बैठिए Professor, 15th Professor C.S. Jha Memorial Lecture. I will now recount the background of the lecture. Professor C.S. Jha Memorial Lecture was instituted by the institution in memory of Professor C.S. Jha, born on July 1st, 1934. Professor Jha obtained his BSc Honours in Physics from Patna University and thereafter obtained his doctorate from Indian Institute of Science, Bangalore. in electrical technology and subsequently PhD in electrical engineering from Bristol University, UK. Late Professor Jha had been a dedicated teacher and researcher and had introduced several innovations in his classroom and laboratory instructions. He had served consistently to help his students develop creativity and problem-solving skills, acquire communication ability and an awareness of quality, safety, and reliability standards in their discipline, and retain an attitude for lifelong learning. During his long academic career, Professor Jha occupied various prestigious positions in various government organizations like Director of IIT Kharagpur, Education Advisor Technical to the Government of India, Vice Chancellor of Banaras Hindu University. He was also appointed as Chairman of the Recruitment and Assessment Center of the DRDO, Government of India. Professor Jha has been actively involved in the policy formulations of the Institution of Engineers India. Since his election as a fellow in the mid-70s, he had been a member of the Council and of the Committee for Advancement in Technology and Engineering, that is CATE of the institution. Considering outstanding contributions in various research and developmental works in the field of electrical technology, the institution at its 663rd Council meeting held at Hyderabad finalized to institute a memorial lecture in the name of late Professor C.S. Jha to be delivered during Indian Engineering Congress. Coming on to the speaker, I am really honored to introduce our distinguished speaker for this prestigious memorial lecture, Shri Praveen Kumar from IRSC, Managing Director, Dedicated Freight Corridor Corporation of India Limited, and 1989 batch officer of the Indian Railway Service of Engineers, and a leading architect of India's modern railway infrastructure. With over 3 decades of exemplary service, Shri Kumar has spearheaded some of the nation's most ambitious rail projects, bringing deep expertise across planning, design, procurement, and execution. His long association with the dedicated freight corridors placed him at the forefront of India's largest engineering transformations, where he played a pivotal role in commissioning of the critical Rewari-Dadri section, overcoming complex technical and logistical challenges. His experience also includes extensive work with multilateral agencies such as JICA and the World Bank, and guiding the Dedicated Freight Corridor Corporation strategic venture into logistics parks and cargo terminals. A respected authority in EPC contract management, he has authored 2 notable books on railway engineering, reflecting his commitment to professional excellence. An alumni of IIT Roorkee with a postgraduate training in public policy at MDI Gurgaon, Shri Kumar is a strong proponent of technological innovation, championing artificial intelligence-based rolling stock inspection, drone-enabled rail monitoring, and advanced asset maintenance systems. With these words, I am pleased to invite Shri Praveen Kumar to kindly deliver the memorial lecture.
Sound है उसमें? Sound आएगा? Sound. Good morning to all of you. Respected Engineer B.B. Singh, Mr. Akhil Gupta, Dr. Sayali. I am very privileged to be here to be part of this August gathering for delivering a lecture on dedicated freight corridor. Till now, our previous lecturers, speakers were on basically more on science and technology. Now let me take you through how this applied engineering, which is dedicated freight corridor, is one of the most iconic project post-independence. The cost of this project is about 1,24,000 crore. As of now, it is already 96.4% commissioned. And this is basically changing the transportation landscape on Indian territory. It is cutting through 7 states of Indian territory and cutting through about 56 districts of all over India. As of now, we have constructed 2 corridors, namely Eastern Dedicated Freight Corridor and the Western Dedicated Freight Corridor. And now the impact of this dedicated freight corridor is visible on Indian scenario. Now you might be aware that India and dedicated freight corridor specifically, now we are August member of the International Heavy Haul Association of the world. You know, you might not be aware, you might be aware that world over about 7 countries are there, which are the proponents of the heavy haul rail transportation world over. USA, China, Russia, South Africa, Brazil. These are some of the countries, including India. And India has now entered into membership, honorable membership of the International Heavy Haul Association. And we are also member of the Union of International Railways. So this reflects the commitment of dedicated freight corridor towards the transportation, sustainable transportation all over India. Our previous speaker has talked about sustainability, lot many environmental pollutions, and he also talked, Mr. Indranil Manna, that engineering is nothing but taking forward and borrowing from science. And dedicated freight corridor is truly doing all these things because we are using lot many industry partners, we are using lot many innovation, technology, artificial intelligence, which I will try to cover during my presentation. Before I take up the presentation, just I want to give you a very brief overview through a video which has been recently developed by Dedicated Freight Corridor during one of our foundation day. We run our foundation day on 30th of every October. So this is the video that we have created, and it shows about what DFC is doing and why DFC has been created as such. Sound. Kindly sound देखो जरा. दोबारा से start करो.
From blueprints to steel tracks, from ideas to execution, DFCCIL has built
I would say that dedicated freight corridor is the jewel of
India dreamt of a new future with a faster, safer and smarter freight network. A vision to create a dedicated pathway for the nation's lifeline, its cargo. That vision became a mission, dedicated freight corridors. From blueprints to steel tracks, from ideas to execution, DFCCIL has built one of the largest infrastructure projects in independent India. Over 6,000 track kilometers of dedicated freight tracks now connecting ports, production centers and people. The eastern and western dedicated freight corridors, two arteries of progress, now redefine how goods move across the nation. India's logistics cost stands at nearly 24 lakh crore rupees, with a transformational impact, helped India to reduce logistic cost to around 8% from 14% of the GDP. Reducing this cost is not just an economic goal, it's a national mission. And the data speaks clearly. The dedicated freight corridors are delivering impact. The national logistics cost is on a declining trend, validating DFCCIL's foundational purpose and giving a strong fillip to India's thriving economy. DFCCIL's high-capacity network offers unmatched reliability, efficiency and sustainability, delivering economic growth on rails. DFCCIL enables industries to move more and spend less. With faster turnaround and energy efficiency, the DFC network is cutting carbon emissions and logistics costs simultaneously. Every kilometer of DFC track reduces road congestion, saves fuel, and contributes to India's journey towards net zero. The next chapter of this express lane of India's cargo is integration, connecting every industry and mode seamlessly to the DFC network. Through multimodal logistics parks, Gati Shakti cargo terminals, private sidings, and innovative logistics solutions with first mile, last mile connectivity and ease of doing business, DFCCIL is driving India's shift from cost-heavy to cost-efficient logistics. With every consignment tracked, every wagon optimized, and every terminal upgraded, DFCCIL is shaping the logistics ecosystem of tomorrow. Offloading freight traffic to the dedicated freight corridor has revolutionized operations across adjoining Indian railway zones. Decongested routes have enabled smoother traffic flow, record punctuality and higher freight loading. During Mahakumbh 2025, DFCCIL diverted 100% of freight traffic from East Central and North Central railways to the Eastern DFC, ensuring seamless operation of Mahakumbh special trains. DFC's operational excellence also helped Dhanbad's division achieve record freight loading consequently. DFCCIL, driving efficiency, reliability and national pride. DFCCIL has been at the forefront of adopting and collaborating on several of India's first innovative solutions for the railways, pioneering technologies that redefine safety, reliability and efficiency. The Heavy Haul Institute not only imparts specialized training, but also partners with leading national and international organizations and institutions, driving innovation through collaboration. With unmatched capability and innovation, DFCCIL now stands among the world's most advanced freight networks, a proud symbol of India's excellence. As a leader of heavy haul rail freight transportation, DFCCIL organized Global Heavy Haul Conference in June 2025 to deliberate future technologies of rail transportation. Behind every track, every bridge, every train are thousands of men and women whose commitment built this national dream. Their passion, precision and perseverance define DFCCIL's strength.
Together, we are transforming India's logistic landscape, making freight smarter, faster and greener.
As DFCCIL marks 20 years of perseverance and progress, we reaffirm our mission to be the backbone of India's economic growth, to power industry and prosperity, and to build the corridors of the future. The future of logistics in India, delivered.
That is what taking the engineering to the field from the academics. Now let us go through a small presentation which I would try to briefly tell about what DFC is doing and why the DFC has been created as such. DFC has been created, you know that Indian Railways primarily before the DFC used to carry the mixed traffic, that is passenger traffic and the freight traffic. You know that passenger traffic is always given the preference. Therefore, freight is basically lagged behind. You know that earning from the Indian Railway, the total kitty about 70% is coming from the freight network, freight logistics, and only 33% from the passenger network. That is why in 2006, Government of India has thought that why we should not segregate this passenger and freight traffic. So that is the basically birth of dedicated freight corridor in 2006. After that, we have started going for the land acquisition, which is very, very huge because we have to acquire the land in 7 states, and every state is having some difficult scenario, different land acquisition frameworks. It caused a very, very huge task on DFC. Apart from that, lot many environmental and sustainable type of statutory clearances are required from the institution as high as Supreme Court of India. So let us talk briefly about the journey of DFC. I would say that why it is not? Yes, now it is come. So DFC is basically transforming transportation of logistics, freight logistics in India. These are some of the items which already our previous speakers told about that. What are the various gamut of various items to be triggered for reaching Viksit Bharat 2047, and dedicated freight corridor. Of course, infrastructure development company is one of the main proponent because logistics supply chain has to be improved at any cost. Otherwise, we cannot be on the international market. मैंने जो अभी what video I have shown, so that is very important thing that what Munshi Premchand has told long back in one of his story, that प्रत्यक्ष प्रमाण के सामने संदेह को स्थान का डेडिकेटेड फ्रेट कॉरिडोर जो बना है उसके बाद में जो आज की डेट में कमीशन है, इट इज शोइंग द रिजल्ट्स. Why DFC? It is an innovative solutions transforming transportation, strengthening DFC through research and development, because our motto is that DFC cannot go to its heights only by itself. We have to have some partnership with the academics and with the industry. And research and development is also one of the very important focus for the DFC. Otherwise, we will not be sustainable on the international market. And what is our vision for the future? Why DFC? This is very important slide that this is the golden quadrilateral of Indian railway network. And this golden quadrilateral network consists of 16% of the total length of the railway, and which carries about 58% of the Indian railway traffic, while it carries 52% of the passenger traffic. That is why this is the most saturated network in India. And that is the reason why freight has to be segregated, or this golden quadrilateral has to be decongested. That is why this freight corridor has been conceived. You know that if we take the journey right from 1950-51 till date, earlier road share used to be 12%, while rail share was 82%. Now, over the period of time, as railway has not gone along with the road, now the road share has now 74%, and rail share is very low. It is about 26%. And you know that railway is one of the most important medium for the environment, for the sustainable transportation, because we are totally electrified. Of course, I am very proud of telling you that Indian Railway is 100% electrified. Partly it is going, partly about 1,000 kilometers will be electrified very soon. And DFC right from beginning has been conceived with the total electrification. Now modal share of Indian Railway or DFC put together is 26%. We want to increase to 42%. Only with the main motto that we want to be more sustainable on the national front. I already told that freight earning about 67% and passenger earning 33%, which is a basically important thing why this freight has been segregated. DFC is an innovative solution. Now these are the two corridors, that is, it starts from Ludhiana in Punjab and goes right up to Sonnagar, and from Sonnagar it is also being extended up to Dankuni, which falls in West Bengal in Bihar, and this will be going for the connectivity to the Dankuni. And the western corridor starts from Dadri and goes right up to JNPT Mumbai. Western corridor is basically for the EXIM traffic, export-import traffic, and this is basically for the port connectivity. Total length of project is about 2,843 kilometer double line track. If we convert into track kilometer, it is about 6,000 track kilometer. Through 7 states and 56 districts. Now, what are the various dimensions? What are the various specifications we thought? Indian Railway used to carry still the freight traffic, but we want that in the same path, we should be able to carry very high loads. So that is the reason that our specifications is much higher, and it is equivalent to what is the standard, international standards are there. We are running double stack containers. We are having 32.5 ton axle loads. We can carry about double the load which Indian Railway used to take. Means that in the same path, we can carry much more load, and that is why our logistics cost is much less compared to the Indian Railways. There are some of the other parameters. We can run up to 100 kmph. Now our average speed, because we are running only dedicated freights, our average speed compared to the railway is about 3 times more. Railway used to run about 20 km per hour on an average speed, and while we are running about 55 km per hour. You know that because of this, our logistics cost is quite low. And we are very efficient. We are using very high standards of rails. We are mild degrees of curve and lot of very advanced type of turnouts, so that maintenance efforts are very, very less during operation and maintenance. Just I am comparing that what we have constructed during last 7-8 years, about 2,840 route kilometer converted to 6,000 track kilometer. You can say this is from New Delhi to Kanyakumari. A track has been constructed in the name of the dedicated freight corridor. It is only comparison, but we are having two corridors, Eastern Corridor and the Western Corridor. Now I just want to tell about that what is the total scope of the work. 11,000 hectares of land has been acquired through 7 states. This was the most gigantic task which DFC could do within about 2-3 years of time, and this is creditable, and I am very proud of my employees that who did this job wonderfully well. About 25 crore cubic meter of earthwork has been done. Lot many important bridges, iconic bridges are there we have made. That is 62 numbers of iconic bridges. This bridge photograph is Narmada Bridge in Gujarat. It is about 2.5 kilometer long, but only for the freight corridors. Major bridges 535, minor bridges 4,643, mean that every project in itself is a project. A big project is having so many little projects. Rail flyovers, we have taken a conscious decision that we would not do any surface crossing. So all the crossings has been done, replaced by the rail to rail flyovers. It provides seamless connection from the railways to DFC and DFC to railways. ROBs, we don't have any level crossings. We are totally about 830 level crossing we have eliminated. So now there is no level crossing on the dedicated freight corridor. These are number of underpasses, means that 557 and 304 underpasses, overpasses been completed, commissioned, and there is no level crossing as of now. We are having 115 stations. We are having stations about 40 kilometer distance, while railways having about 8 to 9 kilometer. Because we don't carry passengers, we are having 40 kilometer. That is why our cost is slightly less compared to Indian Railways. Western 49, Eastern 66 stations are there. National highway crossings 79. These are our operational control centers. For the Western Corridor, we operate these trains sitting at Ahmedabad, and for the Eastern Corridor, we operate our Eastern Corridor trains sitting at Prayagraj. I would invite all the members who are here to visit our control center. This is a state-of-the-art, world-class control centers, totally automatic. I would like, and I would be very cheerful if you come and visit our control centers. We will facilitate your visit in our control center. This is State Eastern Corridor Control Center sitting at Prayagraj, which is very near to here. This is a Heavy Oil Institute at Noida. This is used for both training and for the research and development. And on the right hand side, this is our corporate office, new corporate office. We have shifted very recently in February 25. And this is a state-of-the-art corporate office, and the entire office is being basically working from here. It is also situated in Sector 145 Noida. Anybody wants to visit our corporate office, you are welcome. Transforming transportation. When I am calling that DFC is basically a game changer. In what capacity? Higher capacity, faster, speed is higher, double stack containers, longer, we can combine 2-3 trains put together. We have made a record combining 6 trains together, and total length of the train was 4.2 kilometers. That was one of the record that DFC has made. Of course, that run was empty train. Now we are planning to run with a loaded train. And the world record, of course, it is very high. And world record has been made by South Africa, which carried 80,000 tons in one go. By combining 6 trains, it is a world record. We want to break this world record, of course. This is my vision. I want to carry about 1,50,000 tons in one go. Quantum jump in transportation capacity. 480 additional trains can be run on Eastern Corridor and the Western Corridor. 120 trains each way. Why? Because we are running the automatic block section. We are having 2-kilometer interval signals are there. The automatic trains are moving, and one after other the trains are moving. There is no precedence required like we require in the passenger network. One after other trains keep on moving. We are also providing the Kavach, that is train protection warning system, so that two trains should not collide with each other. Reduction in logistics costs through increased efficiency. Whatever factors I have told, actually everything is contributing the increased efficiency. Green railways, 457 million ton of carbon dioxide emission over 30 period of time will be basically eliminated, or it will not be produced. Released capacity on Indian Railway, because we have segregated freight traffic to the extent of about 80% from the adjoining railways like NCR, like NWR, like Northern Railway, like Western Railway, like Central Railway. Now they can run passenger train to a very high punctuality. And punctuality of the railway trains has increased from 45% to maybe 90%. Development of industrial hubs. I always say that dedicated freight corridors are the spinal cord of the nation. And this very solid network. And now the people and vendors are looking that because we are a credible type of organization and we are running trains as per the timetable, just like passenger trains, lot of vendors, lot of private parties are now requesting DFC to connect with our network so that their transportation, their freight can reach in time without any hassle. Hassle-free transportation. Focus on innovation. Heavy Haul Institute we have made basically to partner with industries, partner with academics. I'm very glad to tell you about that 2,843 kilometer has been commissioned, barring about 100 kilometer connecting with the JNPT, that is Bombay. We are already 4% of the Indian Railway network, while we have started carrying about 13% of the total freight being carried by the Indian Railways. Number of trains, this is the impact of DFC. How many number of trains we are running, this picture shows about that. This again a very, very high impact that coal has to be transported from Dhanbad area to the northern thermal power plants. Earlier it used to take about 48 hours, 72 hours. Now we can take this coal from Dhanbad area to the eastern part of the region, to the northern part of the region within a 24 hours time. And all the transportation almost have reduced by half. So our credible organization and our transportation capacity is very, very high because we are a high speed, high output network. We can deliver the logistics within a short timetable. What are the engineering solutions that we are going in DFC? This is one system that we have recently installed, that is what is known as machine vision inspection system. Of course, this has been made in India with a startup seated at Hyderabad, Bangalore. What we do, a train rolling stocks moves at 100 kmph speed. So all the parameters are being scanned by this machine vision inspection system. It has been powered with the artificial intelligence. If any defect is noticed, immediately it calculates and immediately it informs the control center so that we can stop the train and we should see what are the various defects. This is one of the very innovative solutions that we have used with the help of our local know-how. This is a drone-based inspection. You know that for the inspection maintenance of the track, we have to take some blocks because once the train is running, we cannot take any maintenance inspection activities. What we are planning, we have already given a work on a POC to a startup based at Noida, that while the trains are moving, the drone can also move behind or front of the trains so that they can inspect the train automatically. If any defect is found, they can again, on the basis of artificial intelligence, smart calculations, they can tell any defects to control center and we can take immediate steps for rectification. Rail grinding. You know that our rails are the costliest asset of the infrastructure. It's very, very costly. And if rail is maintained properly, its life can be increased. In Indian Railway, life of any rail, 60 kg rail is about 800, maybe about 10 years. Now with the help of this innovative grinding, which we are using, we can increase the life of the rail by 20%, 25%, which we are doing and which we are doing in a great way. This is track recording car. Inspection and monitoring is very, very important. These are the state-of-the-art smarts backed by artificial intelligence, track recording car for the track inspection and OHE recording for the wire inspection. We have procured this and now these are running. Track recording car is running and for the proper smart inspection of the track in DFC. Hot axle box detector. You know that rolling stocks are running now maybe about 700 km, 800 km in a stretch. So axle box level, they becomes hot. Before they get derailed, might derail if the hot axle is not working properly. These are indications given by the hot axle box detector in advance, so that potential derailment can be basically avoided. This we have introduced at large number of stations. This is a broken rail. Broken rail is also one of the very, very important aspect. If any rail fractures happens, train can derail. We have given 2 orders, one to IIT Roorkee and one to IISc Bangalore for doing some research on broken rail. If it happens, it is a catastrophe. So these 2 works have been awarded to the IITs and IISc. Let us see what comes next. This is top of rail lubrication again for the rail maintenance. If it is maintained properly, life of the rail can be increased to a very high level. Dedicated information management system. We have installed our own made dedicated freight information system. This again doing wonderfully well, and that is why our train operations are being handled by this DFIS system. Predictive maintenance. We always talk about the predictive maintenance. Our lot of infrastructure gears are basically equipped with the predictive maintenance. Before it is going to fail, basically our smart gadgets tell that you have to maintain, you have to go to the site and you have to maintain the infrastructure. We have established one society, that is Center for Heavy Haul Rail Research and Development, situated in Noida. Heavy Haul Institute is basically working under this society. Society is a not for profit society. So this is the society that we have created only to have some understanding between the industry and between the academics. We have signed many memorandums with various international institutes. MXV is a US-based company. Plaza is a Austrian-based company. Lorem is a US-based company. We have signed MOUs with IIT Delhi, IIT Roorkee. Many Indian companies we have also formed MOU. The basic purpose that we want to take the research and development and training to a very high level. What is the vision for the future? We are not restricting that only these corridors are commissioned. What about the next? These are some of the future corridors. You know that. Eastern corridor, the eastern from Ludhiana to Sonnagar, and the western from Dadri to JNPT. Apart from that, north-south corridor, that is from Dadri to right up to Chennai. East-west corridor from Kharagpur right up to Bombay. And the east coast corridor, Kharagpur to Chennai, and southwest corridor is from Chennai to Goa. These are some of the future corridors which we are contemplating, so that entire golden quadrilateral is basically converted a segregated system of freight network and the passenger network. Pardon? Northeast, as of now we are not, Government of India has not, because a lot of traffic is not there as of now. I told that this golden quadrilateral is having the maximum saturation, 16% of total traffic. And north frontier, that is towards the north frontier area, actually traffic is not very high. Maybe in future we might think of making some dedicated freight corridors also. On the accomplishment of the dedicated freight corridor, our Minister of Railways, Mr. Ashwini Vaishnaw, has remarked not once but twice, DFCCIL has not only created new ways of project execution, it is also setting new benchmarks in the way Indian Railway has to evolve in future. I declare DFCCIL as the jewel of Indian Railways. DFC has done a wonderful job. As an MD, I am not boasting, but impact is visible. Even if I say nothing about DFC, but it is creating impact. Our Honorable Prime Minister of India, during one of his inauguration, that both EDFC, that is Eastern Corridor, and the Western Corridor are being seen as a game changer for the 21st century. Our topic of today, innovative engineering solutions for which is Bharat 2047, Dr. Siali. Basically, DFC is very well fits into that because ours is a sustainable mode of transportation. Our logistics cost, definitely national logistics cost will be reduced. We are a very highly efficient system, just on the lines like in Australia. In Australia, generally trains are more of the freight trains. They start from the pit mining area and goes right up to the port. So we are like that. Western corridor basically starts from Dadri and goes right up to the port. So we are a very efficient network, and I hope that future corridors will also contribute for the segregation of traffic and the reduction of logistics cost from present 14%. We want to put it in single digit, maybe 8 to 9%. Thank you. If any questions, I am happy to answer because this is a basically practical type of engine, because this is engineering which has been basically shown the day. If any questions, I would be very happy to, yes. Pardon, sir? Jharsuguda Paradip is also under consideration for the separate dedicated freight corridor because this is a heavily saturated route. So all these things are being seen, and let us see because this is a capital capital intensive. 1 kilometer of double line track, dedicated freight corridor, cost about 75 crore per route kilometer, including land acquisition. It is a very, very highly cost intensive. Lot of funds are required to be generated. Our 2 corridor which has been commissioned, it was with the help of World Bank and with the help of Japanese funding. But Government of India may in future might not take loans from this multilateral agency. They might go for the various Indian finance company like IRFC, like PFC, like RECs, like HUDCO. So we are contemplating, we are deliberating that how this capital intensive projects can be financed locally. What I'm not able to understand. High speed passenger transportation or freight transport is high speed. That is 100 km is high speed only. World over 90 km per hour is a high speed transportation because more than that is not required. You can never find world over that a maximum speed of transportation which were designed, it is 10 km more compared to what Australia is moving. That is 90 km per hour. So for freight transportation and from the cost point of view, increasing the speed of the freight transport is basically not cost effective. This 100 km is more than sufficient for the freight transportation in India. Yes. Actually, from 26 to 42. Now, only DFC will not be able to contribute. Indian Railway has to take lot many other measures because you know that even after we make this freight corridor, as of now about 2,843, if we add 2 more corridors, if you add 4 more corridors, it will add to 8,000 route kilometer more. But railway network is about 66,000 route kilometer. So railway has to take lot many innovative actions to increase the modal share from the 26% to 40%, 42%. Of course, we will be a major contributor for this increase from 26 to 40%, but Indian Railway has to take, which Indian Railway is taking a very, very proactive steps. Yes. 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 What is the status? Yeah. Yes. Yes, very good question. The purpose of this, making this freight corridor, especially for the western corridor, is a double stack container. Basically transportation through containerization. You might be aware, once this box, the humble box, what we know today is containers. That has been basically conceived by a person based in USA, and this was published in Economic Times long back by name Humble Hero. So containerization has made a actually giant leap in the transportation. Now thing is that your question is multimodal logistics. Now once this dedicated freight corridor has been commissioned on the western corridor, because western corridor is basically for the port connectivity. Apart from port connectivity, lot many internal container depots is also planned on that network. Similarly on the eastern corridor is basically a internal container depot type of multimodal logistics, because Dankuni is the only end point where we are connecting with the port. Now on the DFC, we are having lot many port connectivities. And regarding the multimodal logistics parks, on the Gati Shakti policy, we are acting very proactively by deliberating with the customers. You come and connect with this. And in this regard, I would be very happy to tell India Gujaratni Sanjali, a private freight terminal, investing about 100 crores by connecting through our network in the name of multimodal logistics parks. So DFC is basically more for the multimodal logistics parks, and as of now, on the western corridor, we have considered about 6 multimodal logistics parks, apart from private freight terminals. On the eastern corridor, we are having so many internal container depots. In the Dadri area, we are having ICD, a separate company is there, National Industrial Corridor Development Corporation of India. They are making $1 billion multimodal logistics parks in Dadri and one in Rajasthan known as Nagal Chaudhary. So many multimodal parks are now coming, because now we have created a credible type of transportation system, and this will proliferate by of its own because we are a assured network.
Sir, it would be great to continue the conversation over lunch.
During lunch, okay?
Yes.
Okay.
Thank you,
Thank
sir.
you. We will discuss during lunch. Thank you.
We sincerely thank Mr. Praveen Kumar,
Thank you.
MD of DFCCIL, for delivering the 15th Professor C.S. Jha Memorial Lecture in this great hall. I sincerely request Engineer V.B. Singh, sir, to very kindly felicitate our esteemed speaker, Mr. Praveen Kumar, sir. Ladies and gentlemen, a big round of applause, please, for our esteemed speaker of the 15th Professor C.S. Jha Memorial Lecture. Our speaker was Mr. Praveen Kumar, MD of DFCCIL. I shall now request Major General Dr. M.J. Sayali, sir, to formally thank our speaker, Mr. Praveen Kumar, MD DFCCIL.
Engineer V.V. Singh, President II, Mr. Praveen Kumar, Managing Director, Dedicated Freight Corridor Corporation of India Limited, distinguished past presidents, council members, delegates, guests, ladies and gentlemen, it's my proud privilege and pleasant duty to extend a formal vote of thanks to our esteemed speaker, Mr. Praveen Kumar, who has graciously spared his valuable time to deliver this insightful lecture. And in fact, we are so proud that India is moving towards such a high infrastructure growth, and this dedicated freight corridor will definitely help us in moving our goods much more faster and in adequate volume. And in his lecture, he gave us a very clear and compelling understanding of this entire subject. His presentation seamlessly combined technical depth with strategic vision, leaving the audience enriched with his fresh perspectives on these vital themes. We are truly grateful to him for this thought-provoking and engaging deliberation that has broadened our appreciation for the challenges and opportunities that are before us. And now, to honor him and the team that he heads of dedicated freight corridor, may I request the audience to kindly give him a standing ovation. Thank you, sir.
Thank you, sir. Ladies and gentlemen, we shall now proceed to a very special and distinguished section of the 40th Indian Engineering Congress, the 47th Sir R.N. Mukherjee Memorial Lecture, organized by the Institution of Engineers, India. This memorial lecture has been instituted by the Council of the Institution of Engineers, India, in honor of Sir Rajendra Nath Mukherjee, the first Indian president of the institution, to commemorate his extraordinary contributions as an engineer, visionary industrialist, and nation builder. The first Sir R.N. Mukherjee Memorial Lecture was delivered during the Diamond Jubilee celebrations of the institution in 1980, and Sir R.N. Mukherjee exemplified the union of scientific temper, technological excellence, and social responsibility. A pioneer of modern engineering and industry in India, his legacy continues to inspire generations of engineers to apply technology for national development. At this juncture, we are also conducting our technical session concurrently.
Just, I forgot to tell about that, the journey of DFC. You know that in any organization, even in the academia, you always forget to document the history of anything we create. Now we took a challenge since last 2 years, and our team is also here. Please come over here, our team from DFC. We took a challenge that we must document the construction of the DFC. So this is a book that we had just out, that is revolutionizing freight transportation India dedicated freight corridor from vision to reality. On this occasion, I want to give this book to Mr. Devi Singh. I think it will be wonderful to have a copy.
We sincerely thank Mr. Praveen Kumar sir for honoring our esteemed panel of the Institution of Engineers India on this grand stage. With our sincere gratitude to Mr. Praveen Kumar, MD of DFCCIL, we now invite our speaker of the 47th Sir R.N. Mukherjee Memorial Lecture, Mr. Akhil Gupta, CEO and Executive Director of Shapurji Pallonji Engineering and Construction. Mr. Gupta is a distinguished industry leader with extensive experience in delivering large-scale complex engineering and construction projects, contributing significantly to infrastructure development in India and abroad. And now, in order to properly welcome Mr. Akhil Gupta, CEO and Executive Director of Shapurji Pallonji, I sincerely request Engineer V.B. Singh, Sir, President, to very kindly present a bouquet of flowers and also to welcome our guest formally.
Mr. Akhil Gupta, Chief Executive Officer and Executive Director of Shapurji, Pelonji Engineering and Construction, past presidents, honorable past presidents present here, my council colleagues, distinguished corporate members, guests, delegates, ladies and gentlemen. Good afternoon to all of you. I welcome you all to the 47th Sir Rajendra Nath Mukherjee Memorial Lecture instituted in the memory of Sir Rajendra Nath Mukherjee, one of the most illustrious and successful entrepreneurs of India and also the inaugural president of the Institution of Engineers India. We are happy to have with us today Mr. Akhil Gupta, CEO and ED of Shapurji Pelonji Engineering and Construction, to deliver the 47th Sir Rajendra Nath Mukherjee Memorial Lecture at this 40th Indian Engineering Congress. Now I request Major General Dr. M.J. Syali, Secretary and Director General of the Institution of Engineers, to formally present the background of the memorial lecture and also to introduce the distinguished speakers.
Thank you, sir. I will now recount the background of the lecture. The prestigious Sir Rajendra Nath Mukherjee Memorial Lecture was instituted in the memory of Sir Rajendra Nath Mukherjee, the inaugural president of the institution during 1920-21 by the institution. The first lecture was delivered during the Diamond Jubilee of the IEI in 1980. Born in 1854, Sir Mukherjee matriculated from the London Missionary Society's Institution of Kolkata. He then joined the engineering department of the Presidency College, Kolkata. After successful implementation of the Palta waterworks for the city of Kolkata, he rose on the national scene to build an industrial colossus and a trading empire. In 1931, the Calcutta University conferred on him the honorary degree of Doctor of Science. He was knighted after his successful construction of the Victoria Memorial Building at Kolkata. Essentially a man of science, Sir Mukherjee practiced technology for the development of the country. Now my privilege to speak about the speaker. I am delighted to introduce our distinguished speaker for this prestigious memorial lecture, Mr. Akhil Gupta, CEO and Executive Director, Shapur Pelonji Engineering and Construction, and Executive Director on the Board of Shapur Pelonji and Company Private Limited. Mr. Gupta is a civil engineering graduate from IIT Roorkee and holds a postgraduate degree in management from IIT Delhi. With over 43 years of leadership experience, he has been associated with some of the most complex and iconic infrastructure projects in India and abroad, spanning roads, railways, major bridges, hospitals, high-rise towers, sports, universities, and landmark structures, including the acclaimed Bharat Mandapam in New Delhi. Before joining Shapur Pelonji, he served as Executive Director Operations and whole-time board member of Afcons Infrastructure Limited, where he drove major business expansion across Africa, South Asia, and Middle East. His earlier leadership roles at Petron Civil, Punjlayed, and Ircon further enriched his expertise in managing large multidisciplinary teams and delivering high-value, high-impact projects. An astute observer of the construction industry, Mr. Gupta has presented papers at national and international forums and has been honored with several awards for professional excellence. With these words, I am pleased to invite Mr. Akhil Gupta to kindly deliver the memorial lecture.
Good afternoon. Before I start, I know we are eating into your lunch time. Can I humbly request all the distinct delegates sitting on this side to come in the middle, similarly from that side? You will provide me a lot of energy to carry on with the last lecture. Please. May I request, sir, if you can come in the middle, I can assure you it will give me a lot of energy. Thank you. Thank you. Thank you for agreeing to my request. Thank you so much. Please, please come in the middle. Engineer V.B. Singh, President Institution of Engineers, and also my senior at IIT Roorkee. Major General Sayali, Secretary and Director General, Institution of Engineers, India. Distinguished delegates, dear friends and students, it is my privilege and honor to be here with you today, delivering the 47th Sir Rajendra Nath Mukherjee Memorial Lecture at NIT Durgapur, organized by the Institution of Engineers. The Institution of Engineers has done yeoman service to the nation for more than 100 years. Since its inception in the year 1920 in Kolkata, due to its tireless efforts through the decades, it is today the world's largest multidisciplinary engineering professional society with more than 1 million members in as many as 15 engineering disciplines. I think we can have clap for the Institute of Engineers. I stand today in the hallowed presence of the National Institute of Technology, Durgapur, which itself has a 65-year-old legacy of excellence in engineering, education, and this certainly adds to my sense of privilege. To add to this, the eminent gentleman in whose memory this memorial lecture is named, Sir Rajendra Nath Mukherjee, who was a civil engineer. He has several achievements to his credit, an eminent industrialist, an engineer par excellence, with several notable projects to his credit, including the Palta Water Works, Victoria Memorial, Old Howrah Bridge, and the Rabindra Setu, and also an institution builder. I am privileged to be called upon to deliver a memorial lecture named in his honor. Well, my life's work has primarily been about creating infrastructure that serves the humanity for a long time, maintaining, repairing, and sometimes saving them is only a natural extension of the work of building infrastructure that I've been doing. And in that journey, I have learned that engineering is not distinct from life. It is only a mirror to it. I personally believe that the engineering profession will play a critical role in the growth of Indian economy, in helping us achieve the goal of Viksit Bharat of the government of India, that is, we being a developed economy by the year 2047. The importance of infrastructure development in this grand objective will be paramount, and engineers will have a leading role to play in it. Today, I intend to narrate a fascinating story Now it will be okay. Yeah. Well, today I intend to narrate a very fascinating story how structures age, how they fail, and they tell us in their own language that they are distressed, how we diagnose them, and how we bring them back to life. Along the way, I would like to show you why the principles of retrofitting. It's okay now? Thank you. Why the principles of retrofitting apply not only to the bridges and engineering structures, but also something to be far more personal, the human body. What I shared with you today is not a technical summary, but in fact a narrative, a story, one that ties together a major bridge across the Ganges, the human body, and with the overall philosophy of renewal. Let's try and understand, when does a structure begin to fail? Not when a crack appears that we observe or when a corrosion is visible, or when the hinges deteriorate. Perhaps, and that is true, a structure begins to fail the day it is born. Because from the very first cycle, the mechanism of fatigue starts writing a silent diary. During my life work in construction of bridges, highways, railways, buildings, airports, convention centers, stadiums, I have learned that structural distress almost always emerges from one of the 6 architectural truths of failure. Let me narrate them not as a list, but as a lived engineering experience. One of the first architectural truth or the causes of failure can be an accident. A structure, a bridge that has stood faithfully for years, maybe decades after decade, suddenly a drifting barge approaches, loses control and hits the pier. Maybe the bridge might get misaligned, or maybe a span is lost, maybe 2 spans are lost. And one of the very well-known example in the recent memory that we had is the Baltimore Bridge in the United States of America. This is an actual photograph of the bridge. That is when spans had collapsed. Now, in such cases, retrofitting is not a choice. It is a necessity to restore the structure to its original role, the service that it is supposed to provide. The quality of construction can be the second cause of failure of a structure. Structures don't fail suddenly. They fail slowly because quality of construction was not good enough in the initial stage itself. Maybe due to improper compaction of concrete, maybe misalignment of the shuttering, maybe boards of structure were not properly aligned, or maybe the structure work was not executed strictly in accordance with the expectations of the design engineer. In such cases, retrofitting is often strengthening a structure that was not strong in the first place. Cause number 3, the quality of design. Maybe the design was not proper. The designer may consider a uniform distribution of stresses when the structure is loaded, while in reality, a small error may lead to huge implications. In field, those implications can be highly punishing or may give rise to severe combination of forces that may lead the structure to a very unique or rare eventualities. Design flaws, they don't shout, they whisper, and until the whisper becomes a catastrophe. Here I would now like to bring to your knowledge a very unique case. It's called the 59-story crisis. I am not sure how many of you heard about it. City Corp Center, built in the New York City, in Manhattan, in the year 1977, was put to good use. Everything was fine. One day, one engineering student decided to undertake her project studying the design of the building. During the design, it was discovered that there were certain errors, and in certain conditions when the wind speed was more than 70 miles per hour during the hurricane season, and US gets a lot of hurricanes, the building can collapse. When it was told to the designer, and designer when analyzed, he agreed, yes, this is a very difficult situation. Now, this was in the very congested and heart of the New Manhattan city, Manhattan, and it was then decided to retrofit this building, creating a mass damper in the center of the building, and it was done secretly. It had to be done secretly because the panic among the people. It's a very congested. In the, I would say, if I am not wrong, around 41st Street and the 4th Avenue, around that area, City Corp Center. So they worked in the night only as a secret exercise to ensure that retrofitting was done and the panic was avoided and maybe perhaps the catastrophe was avoided. So there can be very serious implications where the retrofitting may be required. Misuse. This is perhaps the most underestimated cause because misuse tends to accumulate with time. Misuse doesn't show its repercussions on immediate basis. A bridge designed for 10-ton axle loading, normally we see it is used for 15-ton, 20-ton axle loading. A flyover which is designed for 2 lanes, during the peak traffic hours, it carries 5-lane traffic. Gradually, the different elements of structure start getting fatigued sooner than later. Concrete fibers may fatigue rapidly, pre-stress loss may get hastened, or bearings may deform quickly under overloading. Perhaps, if I can say so, the misuse is not the corrosion of steel, it is the corrosion of discipline. When a structure is not subjected to the loading for which it is designed, and then perhaps we can have this kind of scenario. Poor maintenance. A structure may be designed well, a structure may be executed well, but it's not being maintained. Maybe the funds are not provided, preventive maintenance is not done, then deterioration is inevitable. In this case, the retrofitting is about restoring the dignity of a structure that was designed well, that was executed well, but had been neglected. Sixth, and the last, also is when a structure is designed well, is executed well, is also maintained well, it will age. Thermal cycles expand and contract, steel thousands, hundreds of times. Floods scour the foundations, wind loads cause millions of tiny vibration cycles. Retrofitting here is a tribute to a structure that has provided intended service throughout its design life. While it acknowledges age, but it refuses to accept that it is obsolete because it is serving well. Well, ladies and gentlemen, now let me take you through the journey of one of the most technically challenging retrofitting projects that India has ever undertaken. And I was privileged and honored to be driving that project as member of the board of Afcons Infrastructure Limited and head of the vertical that undertook this project. The MG Setu, a bridge that refused to give up, the bridge that taught us renewal. Let me narrate this story of a bridge that has been part of India's economic lifeline for several decades, and a structure that demanded engineering courage and emotional commitment to take the retrofitting project that I am going to narrate. MG Setu, Mahatma Gandhi Setu, built across the Ganges in Patna. I am quite sure most of the engineers sitting here are aware of this bridge. It is a 5.575 kilometer long, 4-lane road bridge, the longest bridge built across any water body, was commissioned in 1982. This was a masterpiece of its time. It carried the aspirations of the million because it connected the lower and the upper Bihar. There was no other significant bridge in the near vicinity for the transportation of both passenger and the goods. This bridge has 46 spans, each of 121 meter long, built-in pre-stressed balanced cantilever in precast segmental construction. Foundations were on single circular wells of 53 meter depth. However, as soon as the bridge was commissioned in the year 1982, because the demand was already there, in no time it exceeded its design traffic. More than 85,000 vehicles, many of them heavy loaded goods vehicles, started using the bridge. So it started getting stressed. Heavy trucks led to the hammering of the central hinge in a balanced cantilever. It led to deflections beyond the design deflections. Cracks appeared in the precast segments. Water seeped into the segments, and there was a loss of pre-stress in the cables. Within 9 years of its commissioning, that is in the year 1991, there was a need to strengthen the bridge. As it would happen, because it was a lifeline, it was carrying the peak traffic throughout 24 hours. It was decided that external pre-stressing should be done because the loss in the pre-stressing in the cables was observed. So next 15 years, efforts were made to do the external pre-stressing. To do the external pre-stressing, somehow the traffic was carried on. Within 15 years, the expenditure made on the bridge was more than double the cost of the original bridge construction. Now here was the problem when the deflections exceeded. Now the government decided that something need to be done. And that is when IIT Roorkee was commissioned to undertake the condition assessment of the bridge. Well, when the condition assessment was done, it was quite a long drawn exercise. Incidentally, they observed that the foundations are safe, the substructure is safe, and the superstructure need to be replaced. So they advised that retain the foundations, retain the substructure, but modify the pier cap and replace the entire superstructure of 5.575 kilometer length of the bridge. This was like a patient whose limbs had failed while their heart was still beating strongly. So this was not a proposal for repair, it was a proposal for rebirth. This was retrofitting at scale, preserving what mattered and rebuilding what failed. Now let me walk you through the process as it happened on the ground. So you can see the pier is in good shape. Foundation of course are not visible, and you can see that the balanced cantilever portion is visible. You see, the bridge had two separate sides, upstream side and downstream side. So 2 lane plus 2 lane. Since the bridge was still carrying the traffic, it was decided to execute the entire exercise in 2 parts. So first the upstream side was taken where already one span had completely damaged. Also there was a constraint that was very clearly identified that no debris, however small it may be, must not fall into the living Ganges. So you have to dismantle the bridge in a manner that nothing falls into the. So this was not a demolition, it was a controlled surgical dismantling piece by piece over a living river. 50% of the bridge, if you are aware of the Ganges that flows there, 50% of bridge is above a dry bed where a lot of banana cultivation is done, and 50% of the length of the bridge is over the living Ganges. So as far as so dismantling of the bridge. Now when you have a pre-stressed balance cantilever, now dismantling also will pose a lot of safety challenges because it may lead to jerk. So the person who has to cut the cable also has to hang from a distance, from a different location, so that if the span collapses, safety of the individual is not compromised. So you can see that there is a crane on which the person is hanging and he is suspending the gas cutter to cut the cables. These are the finer points that one need to think through before actually undertaking the exercise. So this was not the only challenge. We also have to see that if the span suddenly collapses, that can also damage something else. So we provided the support system in the middle of the span, and then we did that cutting. Long boom, you can see on the right picture, long boom, 26 meter long, 5.1 ton capacity. Long boom jaw crushers were deployed to cut the span that was on the dry beds only. And there also effort was made to spread a sheet so that debris don't mix with the sand. Debris was transported and then processed, that I will talk later in the. Now we come to the wet spans where the challenge of ensuring that nothing falls into the river had to be implemented. So we used wire saw cutting machines like this. We used 100 metric ton strand jacks fixed to the gantries, that when each segment is being cut, they are being held back so that they don't fall. So here is the exercise. You can see the gantries. Once the one segment of 3 meter length is cut, and the maximum weight of the segment was 76 tons. It is lowered on the barges, and the barges are then go to the shore and unload the segments, and then they are taken to the crushing and the processing yards. 76,500 metric tons of debris of concrete was processed, and nothing, I can assure you that nothing was thrown into the river, and river ecosystem was not at all impacted due to the dismantling. We come to the pier. Now pier was supposed to be retained, but pier cap had to be modified because the superstructure now was being replaced from balanced cantilever to simply supported through truss of 121 meter span. So these were hollow piers, and on the top you can see the upstream and the downstream pier caps. Now when we modify these pier caps, because the simply supported truss, suddenly the width increased to 11.2 meters, while the initial pier cap was only 5 meters. So you have to construct a pier cap which is more than double the original width, and hence it leads to the cantilever. Now so there has to be a cantilever construction of the pier cap. You can see the pier cap as a cantilever. Now when you have this modified cantilever pier cap and the superstructure is put on this leads to the eccentric forces and the pier cap. When the superstructure is done and the traffic is put onto it, it will have the eccentric forces. Those need to be provided for. So what we did for that was, before opening the first side which was completed, to opening it to traffic, these were supported with the pre-stressed McCloy bars. So this led to the pre-strengthening of the pier till the superstructure on the other side was completed. So from the photograph that you saw of the bridge, this is how the bridge would look like. The pier caps have been widened, they have a cantilever portion, and superstructure is a through type open web truss. $70,000 tons of structure steel, 8 fabricators we selected who had those capabilities to fabricate these trusses across the country from north to south, east to west. 5,500 tons of structure steel was fabricated every month. At the peak, there were 90 trusses. Each truss had a weight of 720 tons and 25,000 boards for each truss. So 2.5 million number of boards had to be procured of high quality. They had to be torqued and cross-checked. I said that the fabrication was done in the 8 well-equipped fabrication shops across the country. Now we come to the erection. Erection, as I said, 50% of the bridge was on the dry beds and 50% was on the wet beds. Dry bed, we provided the support system through very light designed trestles on which the erection could be done. And that is how it looked like. You can see the support system at the bottom and the trusses are completed, and once the trusses are completed, the support system is removed and shifted to the newer spans. We come to the wet span. How do you erect a wet span 121 meter? So you provide the anchor staging in one of the spans using the barges. You drive the piles and create a staging where now the erection can be done as is done in case of the dry span. So erecting this span is easy. Use the barge, bring the material pre-assembled into smaller parts and erect it. Thereafter, you erect the balance spans through the cantilever method. Now there we found a challenge. The distance between the two piers was not uniform. It varied, it had a variance of up to 1.5 meter. So what we did was that we increased the width of the pier cap so that we can keep the length of the structural steel spans same and make the job far more easy and faster. So what happened, the gap between the two trusses at the end varied. So the link pin that you see, the dark member on the right side, those link pins length had to be of different sizes. So those were designed in advance, and depending upon the gap between the trusses, these matching link pins were erected, fixed. And that is how a cantilever span erection would take place. Now, here also you have a challenge. When the cantilever is being erected and it reaches the 121 meter, it will have certain deflection. Now, in order to ensure that the deflection is such that it lands on the top of the pier cap and not below that, it is erected at a certain upward angle. So that when it reaches there, it is above the pier cap, then it is jacked with the hydraulic jacks, link pins are released, and then it is slowly lowered on the bearings. That is how the completed C spans would look like. Thereafter, the job was naturally very easy. Doing the slab, the crash barriers, other road furniture activities which I have not covered here. And that is how the bridge. I would also like to tell you this bridge, because timelines in our business is very important. We were provided 24 months for the first site for the bridge to be done and 18 months for the second site. Now, in designing the bridge on the first side, we have certain challenges. While the contract provided that you can use the normal E410C grade of steel and also the weathering steel, client insisted that you must use the weathering steel. Why? Because it does away with the maintenance, painting, because a corrosion layer is formed which works as a protective layer. Now, incidentally, this is not manufactured in India, and only one manufacturer, when we talked to them, they agreed to manufacture it. But we lost about 13 months and we could get only 6,000 tons of steel against 7,000. So we approached the client and we requested that you kindly allow the other E410C grade of steel, which is also permitted and which is manufactured by all the prime manufacturers, producers of steel in the country. And that is one. We could expedite the project. And while this side took overall about 36 months, 12 months more, I am pleased to tell you the second side we did in exactly 18 months. That is dismantling of 46 spans, fabrication, procurement steel, erection, everything was done in, and this included the Corona period also. So it's a tribute to those engineers who worked day and night, the client engineers who ensured that the work was facilitated even in Corona times, and this bridge was completed. It's a landmark project that I believe is a very shining example of how a retrofitting can be done and how a project which is the lifeline of such a large population of area, it can continue to serve. And in my opinion, it was not only retrofitted, perhaps it has got a lifespan which is more than what the original designers would have thought or would have considered. So I can very safely say that retrofitting is not only a practical and cost-effective solution to full demolition, but it also very sustainable. we are reducing the carbon footprint. Well, ladies and gentlemen, this is my first part of the talk. I would now like to take you through a narrative that might surprise you and hopefully interest you as well. A narrative that connects engineering bridges with the biomechanics of human body. Imagine a human spine. It behaves like a column with flexible hinge system. The intervertebral discs are compressible hinges. Muscles serve as bracings and tendons serve as tension members. It will be very interesting to see that the causes and the effect in a human body are quite similar to the 6 causes that I narrated in the beginning of my talk. If you have an accident, you may have fracture, you may have a loss of limb, and similar kind of treatment will have to be done. Quality of construction, you are born with certain short foot, some weak legs. Quality of design, something missing at the birth, artificial limbs, solutions also there. Mishandling, misuse, very, very common cause amongst us. Many of us would be victim of this slip disc, spondylosis. Doctor would advise you, you do traction or you do surgery. If that doesn't succeed, put a lifelong waist belt. Quality of maintenance, early aging, deformity, malfunctioning in a part of body or the entire body, aging in the environment, the aging, infirm body, deformity of structure. So I was trying to compare the engineering structures with the human body. And here is a real case study that I thought I must share. A 42-year-old man, intimately known to me, developed a severe slip disc due to overloading, that is misuse, eccentric posture, core weakness. Perhaps all these could be clubbed under misuse, quality of maintenance, or maybe aging and environment, or maybe combination of these. Now the treatment that is provided is treating the symptoms, it's not treating the root cause. Now over the next 15 years, this gentleman had the pain in the back because the compression in the disc caused sciatica pain. So sometime he was immobilized. So there was loss of time. Then at the age of 57, this man started running. Not because some doctor advised him, but perhaps life pushed him into certain disciplined life. Some accidental understanding, accidental guidance to be fit. Now when he started running, his journey of biomechanical strengthening began. He had an improved metabolism, which improved his sleep, he had improved physical health, improved mental health, improved cardiovascular health, improved bone density, overall improvement in the core stability. He had a improved state of life. He was able to take more challenging assignments, more challenging lifestyle he was able to undertake. At the age of 61, he completed his first full marathon, that is 42.194 kilometers. Between 2022 and 25, this man completed all the 6 world marathon majors. If any one of you is aware, world marathon majors means running the top 6 marathons across the world in Berlin, Tokyo, London, Chicago, New York, and Boston. He became one of the oldest Indians to have done this. And as of today, he has completed more than 50 half marathons, and he is not required to visit the doctor at all. He doesn't take any medicine, he doesn't feel the pain, and he is able to carry on his responsibilities without any challenge. And yes, the individual that individual is the one humbly standing before you delivering this lecture today. Well, ladies and gentlemen, what do these two stories tell us? A bridge and a body. They tell us that retrofitting is just not an engineering practice. It has to be a way of life. We have to request our foundations, our structures, our foundations as well, to recognize the distress early, to intervene wisely, not impulsively, as it happened in the case of MG Setu. To strengthen when what is weak, not to discard it. To understand that aging is natural, but decay is not inevitable. And above all, renewal, whether of steel, concrete, or human spirit, is always possible. That is what I am trying to tell. So retrofitting is the art of giving structures a second life. Running gave me mine. As I conclude, I would like to say, particularly to the, I would believe and agree that all are young people here. So all the young people, that you will build extraordinary structures, you will repair those delivered, you will extend the life of bridges, structures, cities, etc. But please do not forget to preserve the life of the most important structure that you possess, that is your own human body, and mind too. And mind too, that is very important. If today, even one of you present here can be inspired to use the engineering to serve your nation, to preserve rather than replace, and take care of your own infrastructure, your inner infrastructure, then my visit to NIT Durgapur has found its purpose. Thank you very much. Thank you, and Jai Hind. Sir, we can talk. I think it is the same one, because I know location was finalized, but the bridge was constructed much later. Yeah. Correct.
Ladies and gentlemen, requesting Engineer V.B. Singh, sir, to felicitate our speaker. We sincerely thank Mr. Akhil Gupta, sir, and for his time and for delivering the lecture on the stage on the occasion of the 40th Indian Engineering Congress. We have Engineer V.B. Singh, President of IAI, felicitating our speaker of the session, Mr. Akhil Gupta, CEO and Executive Director of Shapurji Palonji Engineering and Construction Company. Thank you, sir. And now we request Major General Sayali, sir, to kindly formally thank Mr. Gupta with a vote of thanks.
Mr. Akhil Gupta, CEO and Executive Director, Shapur Palonji Engineering and Construction, Engineer V.B. Singh, President of IAI, distinguished past presidents, council members, delegates, guests, ladies and gentlemen, it's my proud privilege to extend a heartfelt vote of thanks to our esteemed speaker, Mr. Akhil Gupta, who has graciously devoted his valuable time to deliver a lecture today. And in his address, Mr. Gupta has really brought out how this structures, how they can, they will show that they are withering away, they need maintenance. And he, with his lot of examples, he has shown how these were tackled by his company. And the best part was how the human body and this correlation between the two were shown. And he has given us really rich insights drawn from his decades of experience in steering some of the most complex infrastructure projects across the nation and abroad. And his reflections blended strategic vision with practical wisdom, leaving us with a deeper appreciation of the opportunities and challenges shaping the construction and engineering landscape. I trust the spirit of his lecture has resonated with all present, and I also want to share you that, he has made special efforts to be with us. His actual lecture was scheduled yesterday, and the Prime Minister inaugurated the Guwahati airport, and so it had to be scheduled today, and he made special efforts to fly down and be with us. So thank you very much, sir, and I trust the spirit of lecture has resonated with all of them present. And may I request you to kindly give him a standing ovation for all his efforts. And thank you, sir.
Thank you, sir. Now, please allow me to announce that lunch is going to be served right now, and from 3 p.m. in this hall, we are going to be conducting the annual general meeting, the 106th annual general meeting. Simultaneously, the alumni meet shall be happening right now from in room number 402, and also the women engineers meet.
Sir, 15 minutes lunch, sir, and after that we meet in the alumni. Yes, sir. We can go straight away. AGM will start at 3. Or we'll have afterwards. No, AGM we can, after the AGM, otherwise other thing is that we can do it after the AGM.
इसलिए मॉर्निंग में डेलीगेट्स नहीं आए, प्रॉब्लम ये वो स्पीकर आ गए थे, देयर वर 2 स्पीकर्स.
Sir, if possible, if you could share your presentation, and it will help you. Definitely, sir, definitely. Connected with us only. You tell him to send it to me. This notice is addressed dated 26 November 2025 to all corporate members of II. The 106th annual general meeting of the Institution of Engineers India will be held at National Institute of Technology, Durgapur on 21st December 2025 at 1500 hours. Agenda: firstly, to confirm the minutes of 105th annual general meeting held on 22 December 2024 at Kolkata, already circulated in February 2025 issue of II News, volume 31, number 11. Secondly, to receive the annual report of the Council and the audited accounts of the IEI for the year ending on 31st March 2025. Thirdly, to receive the report of the Council on election of President and also the composition of the IEI Council for the session 2025-2026. And fourthly, to appoint the auditors for the year 2025-2026 and to fix their remuneration. Signed by Major General Dr. M.J.S. Siali, VSM retired, Secretary and Director General.
Thanks to our SDG. Now I take up the agenda. First item on the agenda is confirmation of the minutes of 105th AGM held on 22nd December 2024 at Kolkata. The minutes of 105th Annual General Meeting have been circulated in March 2025 issue of II News, Volume 31, number 12. So, till now, I think no observation have been received. So, can the minutes be confirmed? Thank you. Thank you so much. Then second item is A, to receive the annual report of the Council for the year 2024-25. Under the provision of Bylaw 24, the annual report has been drawn up on the state of institution for the year 2024-25 to be presented at this annual general meeting. Please confirm whether the report may be received. Thank you. Thank you. So report is received. Second B point is to receive the audited accounts of the institution for the year ended 31st March 2025. Under the provision of Bylaw 23, the Council has caused a statement of funds of the institution and of the income and expenditure during the past year, terminating 31st March 2025, duly verified and signed by the auditors and presented at this annual general meeting. Please confirm whether the accounts may be received. Thank you. Thank you. So accounts are received. Now I request our Secretary and Director General to report the composition of the Council for the session 2025-26. I am sorry. Actually, before that, one important event is there regarding installation of president, new president. So you will read, I think. नहीं वो तुमने पढ़ दिया. So I have great pleasure in announcing that the Council of the institution has duly elected Mr. Manish Mohendra Kothari, Fellow of the institution, as the President for the session 2025-26 as provision under Bylaw 5. So let us give again a big hand. And now our installation will be.
Moria. Dignitaries on the dais. My friend, mentor, guide, our immediate past president, VB Singh sir, all the mentors sitting in front of me, all the past presidents, my dear council members who have given a faith in me to lead this organization, the age-old, the legacy organization. Ladies and gentlemen, very good afternoon to you. Good afternoon. It's a profound honor to stand before you this afternoon on 21st December. The quietly glows in the chronics of scientific endeavor. On the very day in 1898, Marie and Pierre Curie first isolated radium, revealing a phenomenon that would change the course of physics, medicine, and modern technology. And on 21st December 1968, Apollo 8 soared into the space, the first human mission ever to leave Earth's orbit. Circling the moon and returning safely, these two achievements, one in the stillness of the laboratory and the other in the thunder of the Saturn we launched, remind us the boundless horizon unlocked when the science of engineering coverage. We gather today in Durgapur, a city that continues to embody the spirit of engineered ambition, convinced as one of the independent India's earliest planned industrial cities. Durgapur stands at the testament of what determined minds and coordination engineering can accomplish. Its furnaces, rolling mills, power plants, and technical institutes have long served as crucibles in innovations and industry. To meet here for the 106th Annual General Meeting and the 40th Indian Engineering Congress is a reconnect with a living legacy of the Indian engineering excellence. As I take up the responsibility of President for the session 2025-26, I extend my heartfelt gratitude to the Council, our centers, our local centers, state centers, our overseas chapters, our divisional boards, committees, our staff, above all our corporate members, our websites and documents, our works. But the real IEI thrives in your dedication and your belief in the institution. I speak a bit about the legacy. As we look to the future, it is essential to draw strength from the century-long legacy that defines the institution of engineers since its inception in 1920. And formal inauguration in 1921, IEI has grown from a small collective of pioneer engineers into a national institution and upheld breadth and influences, from shaping early engineering standards and advising governments on industrial and infrastructural development, to guiding India's response during wars, droughts, and periods of reconstruction. IEI has been woven into the fabric of the nation's progress. The conferment of Royal Charter in 1935, one of the earliest such honors outside Britain, further elevated IEI as the custodian of professional ethics, engineering excellence, and public trust, and reminds us the IEI has repeatedly resigned the national challenges with the knowledge, courage, and unity. The heritage is not merely a chronic of past achievements, it is an enduring call to preserve, enhance the pride, dignity, and stature of engineering profession for a decade to come. The year ahead unfolds at a time of rapid transformation. Artificial intelligence, advanced material, green energy systems, resilient infrastructure, climate responsive development, and the renewed trust in the space exploration. India is also preparing for significant regulatory reforms on the engineering domain in such a movement. IEI must not simply respond to change, it must help define the contours of enduring proportions. Friends, today I'll speak about my agenda or the mission or the 5 points which I'm going to behold or give the priority in my tenure. I'll try many things, but the priority 5 things I think I should work on it. First is, obviously at my heart, my members of the Institution of Engineers and the new engineers who should be the members of IEI. Transform membership into deputy marginal value experiences. IEI immediate responsibility is to strengthen the core services that directly support our members. Our extensive network of centers, divisional boards, forums and technical bodies provides strong foundations for delivering consistent and dependable services across the country. Our priority is to ensure that every aspect of membership, enrollment, renewal, certification of other interaction becomes simpler, faster and more transparent by streamlining workflows, improving turnaround times, strengthening ERP and membership portals, and bringing greater uniformity across centers. We can create a reliable service ecosystem that meets the expectation of today's professionals. Enhancing the responsibilities and empowering communications are practical steps firmly within our reach. The second agenda is elevate IEI's technical activities into engines of the thought leaderships. IEI technical activities must reflect current industry needs and emerging opportunities. While our divisions and centers already conduct numerous events, there are substantial scope to align our programs with areas of immediate demand: manufacturing, infrastructure, water resources, material, safety, energy, systems, and ICT applications. Through closer collaborations with industry, academia, and government bodies, centers can develop hands-on workshop, refresher courses, and region-specific training modules and address real skill gaps. Such initiatives will deepen IEI's technical relevance and strengthen our role of professional development nationwide. Third, build a credible, modern, and respected system of certifications. We are already a certification body, but we should try to build, it should be and have some credibility to our members, to our the certification authorities. IEI's role in certification and skill development now carries national significance. Our dual recognition by NCVT as an awarding body and assessment agency gives us clear mandate to design qualification packs, develop assessment framework, certify professionals, and support the country's skilling ecosystem. By coordinating the efforts of the National Skill Development Forum, divisional boards, SKI, and centers, IEI can create industrial relevant certification programs and assessment service that benefits technicians, supervisors, and engineers across sectors. These are responsibilities we are structurally equipped to deliver, and their expansion will strengthen IEI's impact on the workforce development. Fourth point is enhancing digital infrastructure for institutional efficiencies. Digital modernization remains fundamental to our progress. Much of IEI services, delivery, membership management, examinations, financial reporting, record keeping, and communication depends on the robust, secure, and upheld digital system. Strengthening our ERP, ensuring that data accuracy, improving cybersecurity, and designating create-level opportunity will head a greater consistency and transparency across the institutions. These improvements are not theoretical constructs. They require disciplines, implementations, and sustained monitoring. Well within the IEI's organizational capability, a trustworthy institution must operate on the trustworthy digital architecture, and building such an internet of trust and essential for delivering fair, efficient, and accountable services. Fifth, last but not the least, financial strength. You all know that Institution of Engineers once upon a time was having a very good strength in finances, but together we will try to again have a financial strength. Financial strength, the bedrock of the institution on excellences. IEI's aspiration must rest on strong and stable financial foundations. Our growth depends on strengthening predictable and renewable seasons such as training programs, certification services, consultancy, publications, examinations, and partnerships with industry and government. Centers with adequate facilities can be encouraged to run regular professional courses and structured activities that utilize their infrastructure effectively throughout the year. Equally important is financial discipline, uniform accounting practices, timely reporting, and technologically enabled financial systems which ensures transparency and accuracy. These measures are practical, achievable, and essential for sustained IEI and future initiatives. The road ahead, marching together as keepers of a noble profession. No president, council, or directorate can realize this vision alone. IEI advances only when all its arms move together. Our centers extend our outreach. Our divisions sharpen our intellectual engagements. Our fora amplify our collective voices. Our employees safeguard continuity, and our corporate members give us identity and purpose. When these elements work in harmony, IEI becomes not just an institution, but a movement guided by the shared responsibility. Let us uplift young engineers and opportunity, uphold professional integrity and conviction, and strengthen our contributions to national development. Let us honor the legacy of our founders and building an IEI that is modern in its system, steadfast in its values, and unwavering in its service to the society. As I accept humbly the responsibility you have entrusted to me, I pledge to lead with openness, dignity, and determination. I will listen, I will engage, I will act with the singular aim of strengthening IEI and elevating the pride and standing of the engineering fraternity of India. Friends, this can only be done with all your support. And I am very much confident, and I know that your support will be 100, no 1000% behind me to grow our IEI. Our mission for this year will be the strength and grow and the glory of IEI. With these three slogans, we will go ahead, we will start, we will do, together we can accomplish. Together, let us write a new chapter in the history of the Institution of Engineers India. A chapter defined a relevance, credibility, and national pride. Friends, once again, from the bottom of my heart, I thank you for giving me this opportunity to serve the Indian engineering fraternity of India. Thank you for the patience hearing, and Jai Hind, Jai Bharat. Friends, coming to the next point, I request our SDG sir to report the composition of the council for the session 2025-2026.
Thank you, sir. The composition of the council for the session 2025-2026 shall be as follows under provisions of various bylaws. Mr. Manish Mahendra Kothari, President. Under provision of bylaw 4A2, the following by virtue of there being the two immediate past presidents shall become members of the council for the session 2025-2026, Mr. V.B. Singh, Dr. G. Ranganath. Under the provision of bylaw 4A3, the corporate members elected to the council from the following state centers for session 2025 to 2029 shall be members of the council for the session 2025-2026. From Delhi, Mr. Devendra Gill. From Gujarat, Mr. Gandhi Jayesh Ajit Bhai. I'll request the members if they can rise and the others can identify them. Delhi, I'll repeat again. Delhi, Mr. Devendra Gill. Okay. Gujarat, Mr. Gandhi Jayesh Ajit Bhai. Is there? Maharashtra, Mr. Anand Vaman Rao Javanjal. Odisha, Dr. Parvat Kumar Padi. Tamil Nadu, Dr. V. Karthikeyan. Lango, okay. I am talking of state center to council. Telangana, Professor Dr. Ramanna Banutu. Uttar Pradesh, Mr. Avdesh Kumar. West Bengal, Mr. Sujit Kumar Banerjee. The corporate members elected to the council from the following state centers shall continue as members of the council for the session 2025 to 2026. Elected for the sessions 2024 to 2028, Haryana, Mr. K.C. Sethi. Punjab and Chandigarh, Mr. Sukhveer Singh Mundi. Elected for the sessions 2023 to 2027, Bihar, Mr. Ajay Kumar Sinha. Jharkhand, Mr. Sanjay Sen. Madhya Pradesh, Mr. Rakesh Kumar Rathor. Rajasthan, Mr. Sajjan Singh Yadav. Elected for the sessions 2022 to 2026, Kerala, Dr. G. Madhu. Under provision of Bylaw 4A4, the following elected members from the 15 engineering divisions for the sessions 2025 to 2029 shall become members of the council for the session 2025 to 2026. Aerospace, Dr. Venkata Krishna PV. Agricultural, Professor Dr. Nami Chandrappa M. Architectural, Dr. Sandeep Kumar Deb. Chemical, Dr. Raghu Patruni Bhima Rao. Professor Dr. Shilpa Tripathi. Civil, Mr. K. Vijaya Kumar. Mr. M. Nagaraj. Mr. P. Surya Prakash. Mr. Rajesh Bisaria. Lieutenant Colonel Dr. Naresh Pal Singh Bana. Computer, Dr. Baljit Singh. Professor Dr. Chandrasekhara S.N. Electrical, Mr. R.R. Tanwar. Dr. S. Dharmalingam. Mr. A. Shekhar. Professor T.J. Ramamurthy. Electronics and Telecommunication, Dr. Jagtar Singh. Professor Dr. G.S. Mundra. Professor Dr. Mrs. Shobha B.N. Mr. S.S. Mutha. Environmental, Mr. J.C. Singhal. Marine, Captain Dr. B.M. Bhandarkar. Mechanical, Dr. N.T. Rangareddy. Dr. G. Venkata Subbiah. Dr. Mrs. K. Padmani. Mr. S. Karpaswamy. Dr. Nilaj Kumar Najuk Rao Deshmukh. Metallurgical and Materials, Mr. K.K. Mehrotra. Mining, Mr. Velpula Rajkumar. Production, Dr. C. Ram Satyanarayana. Textile, Dr. P. Mohan Raj. Under provisions of Bylaw 4B1, by virtue of being chairman of the following state center for the session 2025 to 2027, following persons have become ex officio members of the council for its session 2025 to 2026. Andaman and Nicobar, Mrs. Usha Stephen. Arunachal Pradesh, Professor Dr. Arvind Kumar Singh. Assam, Mr. Bhaben Kalita. Bihar, Mr. Neel Mani Rangesh. Goa, Mr. Austin Socorro Rodriguez. Gujarat, Mr. Mahesh Bhai Devkaran Bhai Patel. Jammu and Kashmir, Mr. Firdaus Ahad Bhatt. Jharkhand, Engineer Sandeep Kumar Bhagat. Karnataka, Professor Dr. Ramaraju H.K. Kerala, Mr. Uday Kumar K.S. Maharashtra, Mr. Vijay Chandrakant Kamble. Manipur, Mr. Soiban Tampa Singh. Meghalaya, Mr. Konstantin Kharmudei. Mizoram, Dr. L. Lalchonwela. Odisha, Mr. Sangram Keshri Patnaik. Puducherry, Mr. K. Sundarajan. Rajasthan, Mr. Manohar Lal Yadav. Tamil Nadu, Professor Dr. D. Lango. Telangana, Professor Dr. Ramana Banothu. Uttarakhand, Mr. Chandra Prakash Sharma. Uttar Pradesh, Mr. Vijay Pratap Singh. Election to the office of Chairman, West Bengal State Center for the session 25 to 27 could not be conducted due to the order dated 13 February 25 of the Learned Civil Judge Junior Division Alipur Court in the case TS 393 of 2025. Chairman of Chhattisgarh State Center for the election for the session 2025 to 2027 shall become an ex officio member of the council under this bylaw after assumption of office. By virtue of being chairman of the following state center for the sessions 2024 to 2026, following persons shall continue as members of the council for its session 2025-2026. Andhra Pradesh, Professor Dr. MLS Devakumar. Delhi, Mr. Satpal Singh. Haryana, Mr. Rajbir Singh Malik. Himachal Pradesh, Mr. Jaswant Singh. Madhya Pradesh, Mr. Ashok Kumar Sharma. Tripura, Mr. Paramananda Sarkar. Punjab and Chandigarh, Professor Dr. Baljit Singh. Sikkim, Mr. Lochan Kumar Adhikari. Under provision of bylaw 4B2, by virtue of being elected as chairman of the following local centers for the session 2025 to 2027, the following persons have become members of the council for its session 2025 to 2026. Navi Mumbai, Mr. Shashi Prakash Singh. Coimbatore, Dr. Senthil Kumar M. Durgapur, Dr. Bimal Das. Ghaziabad, Mr. Puneet Goyal. Kanchipuram, Dr. Karthikeyan S. Kochi, Mr. Babu K.S. Ludhiana, Mr. Balwinder Singh. Madurai, Mr. R. Narayan Swamy. Mysore, Mr. Suresh Babu H.S. Nagpur, Dr. Sandeep Sharad Shirkhedkar. Nevali, Dr. Suresh Chandra Suman. Pune, Professor Dr. Dattaraya Shankarrao Bormane. South Gujarat, Mr. Ketan Kumar Devendra Bhai Panchal. Salem, Mr. S. Loganathan. Tiruchirappalli, Dr. Kevin R. Kumar. Vadodara, Mr. Kayur Khan Manibhai Thakkar. By virtue of being chairman of the following local centers for the session 2024 to 2026, the following persons shall continue as members of the council for its session 2025 to 2026. Nashik, Mr. Samir Dilip Kothari. Visakhapatnam, Mr. K. Venkata Rama Mohana Rao. Faridabad, Mr. Inderdeep Singh. Under provision of bylaw 13, corporate members shall be co-opted in the council for the session 2025-2026 under provision of bylaw 13.
Respected President and outgoing President, I have a small question to SDG, which he has read the composition of the council. So we have received a letter from him to M. Lakshmana to be a council member elected from the Karnataka State Center. But he has not read the name. Is it by mistake he has not read the name, or any other reason that he has not read? If you tell the reason, then I can explain that what happened in this issue, because I come from the same state. You are a part of all the board meetings, what happened. We are part of the court decisions, and you yourself, Institution of Engineers, yourself fought 4 cases to protect our integrity against the defendant. We won all the 4 cases, and all the court said Lakshmana election is correct. But finally, we are not reading, you yourself are fighting for the institution integrity and the council decision. Now we are not seeing him and we are listening here and there, because as a council member, if you form a committee or any committee is selected, even though you are authorized, we should also get a confirmation or get a communication to their information that so and so committee is there, or anything you have taken a decision. Or if that ERGC is all rumors, because officially I didn't get any information as a council member, outgoing council member or incoming council member. We didn't get information. If any decision is taken, what is circulating in the days, there is an appellate authority as a president last time we declared. So now last time I think I should congratulate the past president. The starting was except little turbulence, because one president has declared one member in the AGM year. He has taken a KNS Prakash Rao from Andhra Pradesh, elected member. But again, next time, again, new president came, says he got a power to remove him and he is nowhere now, he is fighting in the court. And now again, the new president has come now. And I think whatever the decisions are taken, you just follow the things. Don't use somebody's political problems to use your ERGC, or make one past president's committee remove the elected members from the mechanical, or you threaten them that I will give ethical control board. New president, I request you, please stop this type of witch hunting and threatening the fellows. If you ask a question, you put to ethical control board. Or a case closed 3 years back, again you revive it saying that you got an ethical control board notice has come. And somebody talks, you put as some past president committee, remove 4 elected members from mechanical division board. And this is not the way 108 years institution supposed to work. It should be transparent, and if you take a decision, it should be the correct. And again, I don't want to, you should insult outgoing president like what this president, outgoing president has done to the Ranganatha has taken a decision, AGM is approved, and again new president comes and the AGM decision also you overrule it. And who is the supreme here? What is happening? Now he is ready, he has sent a message to him, and he has not sent a message, you don't come for the council, the AGM meeting. And now his name is not read. I think I request all the corporate or council members, please protect the institution of engineers' integrity. Don't witch hunt and don't do a political decisions. Again, it will be overruled by the court. Same institution of engineers fought in the 4 courts. You are almost got a 6.5 lakhs bill. You won all the places. You won all the places saying that the person who is given a complaint is wrong. But you decide against the court saying that courts are wrong and you are correct. President, please see that appellate authority is there. Protect the integrity and protect the transparency. Don't do hitch hunting. Asking a question is something wrong, then you never run an organization for 100 years like this. If something wrong, it is a wrong. There is a provision to correct, you correct it. But don't just go to the fancy and all the things. I think SDG, I don't know whether instructed, you would have read that reason. While reading that, I send a mail to so and so person, but we have decided like this. Under what reasons you decided to explain us. You are just keeping in the blank that what happened is no, every corporate member I have a right to know that you have sent a message and you are withdrawing, or for what reasons. And people should know ERGC is there, they have some powers. Again you have a president, appellate authority is there, president can overrule ERGC decisions. Let all corporate members understand, or you circulate by mail. It becomes like that, no, whatever you do on this year as a CEO, it becomes a lot of suspicion that why you don't give explanation when you don't read somebody's name. And you would not have communicated to him. If you are having a case is pending in ERGC, you would not have communicated to him, please come attend a meeting or congratulating from the council member. It makes a humiliation for an individual. Your letter is circulated everywhere. It is covered in the press, everybody congratulated him. And you don't send him a letter that he has been removed or his case is pending. Though you would not have declared when ERGC case pending before your letter is writing, then why you wrote a letter congratulating him come for the council meeting? Don't humiliate a persons. All corporate, if it happens to us, even it happened to me, when your past presidents made a committee or removed, not allowed me to come for the council meeting in Hyderabad, that much humiliation, no council member should happen it. And you don't use these past presidents or somebody putting their own agenda, tell him that do this, do that. I'm just feel very shame that they follow somebody political instruction to whatever decision is required. And I request President, please maintain transparency. If SDG has to explain now why he has not been invited, whether you communicated to him, is the way you treat a person after communicating and you withdraw like this, or you have not sent any mail as per me concerned. Over to the President. I think I request because you are a new President you have taken here, I don't think that I can expect answer from you. because you are no way concerned for this ERGC committee decisions. Maybe past president just now handed over. You have most information, or SDG can explain why this has happened, what is the background of this?
Dear council members, the question raised by our beloved council member N.T. Ranga Reddy is very much correct. But after election, the procedure is over. There is an provision of EGRC is there. If any grievances are there, it has to be put forth in front of them. And the EGRC has to take decision within 60 days. So as per my knowledge, this Karnataka case of Mr. M. Lakshmana, those election results was declared, he was being congratulated and mail was sent to him. I also congratulated him. But I think there is a EGRC meeting was there. And on the 18th, the EGRC meeting took place. And after going through the relevant documents, what documents I have not seen, but whatever documents was submitted to the EGRC members, then the EGRC, I think they had 100% gone through the regulations and the documents, and they might have come to the conclusions that the election what was being happened in the Karnataka, I think it was not as per the some BOS formation, or this thing was not as per the regulations. So as per my knowledge, the entire election of the Karnataka State Center is being withheld, and it will be, re-election will be conducted in Karnataka for state to council and the entire Karnataka Division Board. This is as per my knowledge, whatever I have. Again, I'll just explain, I'll not explain, but I'll assure you that in coming to myself, as you told, I assure you and I promise, I will be abide by the bylaws and the regulations. Nothing will be done wrong. No humiliations, because I'm a part of you. I'm one of you. Though you have given me the seat, but I am still a part of you. I will see that nothing will go wrong. The name of anybody will not be at the stake. Because the name of the council is at the stake, the name of II is at the stake. So I have got that feeling, and I promise that nothing wrong will be done which will spoil the name of the council member individual or the II at the end. I assure you, sir, I will take care. And as this is a democracy, every council member has got a right to speak. I have also spoken many issues down the line last few years. So I think it will be a democracy. I will be transparent. I will see that all the council members are together with me in all the decisions, whatever I take. It will be transparently discussed with everybody, and then only we will go ahead for the growth of II. But regarding this EGRC and the Karnataka State Center, this much I know about the EGRC's meeting which was held on 18th. So I can assure you that after this thing, I will go through the documents, and whatever is there, we will see to it. If anything else, then you can please.
Sir, I just want to add one or two sentences. Sir, in fact, now I appreciate the announcement made by our elected president, newly charge taken our president. But there are general rumors in the public that people are who have been denied. We have lost their cases in the court, and they are coming through the back door and using their influence, and now using the past presidents. See, they are, I don't know, but using the past presidents, meeting their personal goals, selfish goals. So this is the general rumors that is going on in our general council members, and there is no transparency. And EGRC is not a statutory body. As far as our bylaws is concerned, only finance committee is the statutory body. EGRC is constituted by the council itself. So council is the supreme authority for all the actions. Without informing the council, without informing the president, if they just take their own actions, they are supreme. EGRC is supreme.
And who has constituted the EGRC? Council has to constitute. They have to report only to the council. So this a lot of changes are required in this. It is not, that is why the IEA, many people are distancing from the IEA. Many younger generations, when we go them, ask them to become members now, it is it's a political institution. It is selfish. It is some people are parasites on the institutes. They are living only on the IEA. That is the way they are talking. So this kind of things are not allowed to be continued like this. So this is to be explained by SG, so that all the members will be aware what has happened, why it has been done like this, and now why he has not been provided with the copy of the order given by the EGRC. Then he has not been informed. He is in dark. According to that, when he has gotten a letter from the headquarters stating that he has been elected as a council member, then it is the duty, it is a minimum courtesy. It is a minimum courtesy for our colleague to send again communication, please don't make any arrangements to come to Durgapur. He has made all the arrangements, he has purchased tickets. So after making all the arrangements, there is no communication, and orally if you communicate, is it right? So this is something wrong is happening, sir. I think these all the things are to be recorded in our minutes, and next time it has to be again discussed. And if there is no proper and one more thing is what document they are seeing, whom are they listening? When such a great decision or such a serious decision is taken, they have to call the affected people, and they have to call the local committee members, ask for what has exactly happened, without taking anything on a single person who has some sort of affinity to that past president. They are taking this kind of decisions. And it's not correct, sir. This is something somewhere we are going wrong. I expect that please explain what has happened, why he has been not called for, and also this to be recorded. And what, already assured that you will take action, but still that is not sufficient. Let us know what has exactly happened.
मेंबर्स का सुन लीजिए सर पहले।
ऑनरेबल
सर पहले मेंबर्स का सुन लीजिए सर।
पहले हम बता दें अपना।
सर कॉर्पोरेट मेंबर्स का सुन लीजिए सर।
एक मिनट, मैं डॉक्टर सत्यनारायण की बात का लेट मी reply, clarify my stand on this whole issue. Dr. Satyanarayana sir, I tell you that I formed EGRC. No doubt I formed it. Okay? The day I formed the EGRC and today, till today, just a minute. Till today, I have not talked to either chairman or any of the member. Believe me. And moreover, one thing, more thing. President is nowhere in picture. As per the regulations, EGRC, whatever comes to SDG, he has to refer to EGRC, and whatever EGRC decides, the committee gives its report to SDG, and it is clearly written that EGC will inform them. President is nowhere in picture. I tell you, and I assure you, sir, I tell you, I neither know the decision nor the details. Believe me, I don't know. No, I'm just telling, I'm just clarifying my position, that it is. No, sir, now SDG will clarify from it.
सर कॉर्पोरेट मेंबर्स को भी बोलने दिया जाए सर कॉर्पोरेट मेंबर्स को भी बोलने दिया जाए सर yesterday in the SK group corporate we are sitting in AGM, we are corporate members, we shall also be allowed to speak, right sir?
This is as per regulations. This is as per regulations. I think Mr. SDG, please, Mr. SDG, please read out the regulation first. Mr. SDG. Please read out the regulation first.
सर मेरा भी सुन लिया जाए सर.
Regulation, you just read out the regulation.
सर
Sir, just a minute, sir.
सर एक कॉर्पोरेट मेंबर का भी सुन लीजिए सर. साहब लोग का तो सुनेंगे ही. सर प्लीज. Sir, yesterday I got a WhatsApp message in SK group. In that group there are so many members. I got a message from a person of our council that on 18th December there was an order to the Honorary Secretary to act on this case. And in reply to that, our past President Mr. C. Devanath has asked where is the enclosure. Sir, if there is any order of EGRC, as per my knowledge of regulations, sir, incidentally I was chairman of bylaws committee and also the president for some time. I know that there is provision of asking the person concerned explanation. This is the charges against you. He replies and the appellate authority is the president. And final decision is taken by the president. Once the president is saying that I am unaware of that, then why this action, sir? How can SDG take the action? President has to take the decision. Thank you.
President, sir, just a minute, sir. Just a minute, sir. I have a very small sir, suggestion, sir. The issue being discussed right now is related to the report on the composition of council, sir. And the question was raised by Dr. Rangareddy, and he requested the president to respond it. So you see, in this composition of council is a part of the agenda of AGM, which should have been presided by the president, BBC Sahab. And he should have been asked this question. But what we did wrong, procedurally, this is a sheer violation of a standard democratic process, sir. Composition of council is a part of the agenda, and till this agenda, the president should have presided over the meeting. He should have been chairman. Thereafter, the new president-elect should have been installed, sir. Thank you very much, sir.
With the kind permission of President, I am just reading out the regulation 23H. It says the council shall constitute an election grievance redressal committee. The committee shall consist of 5 members, at least 1 from each zone. No sitting council member shall be in this committee. The term of the committee shall be for 2 years. In any meeting, 3 members will form the quorum. However, the election grievance redressal committee members shall not take part in the election in question. Any member aggrieved by any matter arising out of or in connection with the conduct of elections under Regulation 24, 25 and 26 may make a representation to the Secretary and Director General within 30 days of declaration of the result for being placed before the Election Grievance Redressal Committee for its consideration. The Election Grievance Redressal Committee shall investigate, conduct an inquiry, interpret the bylaws or regulations, etc., as the case may be, and communicate its decision to the aggrieved member within 60 days from the date of declaration of the election result. The matter will be appealable within 15 days from the date of decision of the committee. The President will be the appellate authority and his decision will be final. I will also clarify this issue of whether EGRC is a statutory body or not. Since it is constituted under the regulations, it is a statutory body. And I'll also now, because I think there is some council members are not aware, I'll now cover what is the powers of the council. Management. I am speaking bylaw 3. The governance and control of the institution and its affairs shall vest with the council, and the council shall exercise all the powers of the institution and do all duties of the institution with intent to give effect to the provisions of the charter and bylaws for the time being of the institution. Now, sir, the exception comes. except, now the council power is not, except so far as the same are by the charter or by the bylaw, for the time being expressly required to be done in general meetings of corporate members or by the president or secretary and director general of the institution. So president draws his power from whatever is written in the various bylaws and regulations. The secretary and director general draws his powers from whatever is written in the bylaws and regulations. Beyond that, whatever is there in the bylaws, they are supreme. They are, the council has of course the power to amend the bylaws and regulations, but the bylaws, the council has to conduct the affairs of the institution in accordance with the bylaws and regulations. So I'm just clarifying this issue. Thank you, sir.
Hello. As per the bylaw read by our SDG, council has to constitute the EGRC. It is first line what he has read. When the council has authorized the president to constitute the EGRC, it is the minimum, duty of our president to communicate to the council members. These are all the EGRC members. And everything is secret here. We don't know who are the EGRC members. Have you any time, brought in the council meetings? These are the EGRC members. And the report also is to be put into the council. That is also not done. And one more thing is here, only few documents, whether they are authorized or not, whether they are fabricated or probably they would have taken into cognizance while taking the decision. How do you know this? How the council will know this? The authorized documents are only minutes of the state committee meetings. In the state committee meetings, what I got the information is, the BOS's members have been discussed and they finalized the members of the BOS and the state committee has accepted. It is recorded. And subsequently the same BOS members in the next, while approving the minutes, in the next committee also they approved. Those are the two documents which are now important. Not handwritten documents or any other things, are not fabricated documents. How do we know that? How do we know that it is fabricated or created documents? Such kind of doubts should not give when to have this kind of doubts in the minds of the corporate members. So this is what is happening. Everything they are doing under the desk and secretly. What is the necessity to do all these things secretly? And he says that the EGRC is constituted by the council. Have you any time brought to the EGRC? Have you included any time in the council agenda, council minutes? They are the EGRC members. At least you have to communicate of the formation is done. You have not done anything. It is usually the conduit for taking our selfish, attain the selfish goals.
So, President, one small point I want to mention. Sir.
Sorry, sir, Satyanarayana, sir, what did you say? Selfish goals against me. What did you say?
No.
Please get up and please tell me what you have said.
You are
challenging my professional integrity.
I am not talking about SDG. Mr.
You are talking again. You said you.
You are only an employee. Please keep
Sir, whether I am a statutory authority of this institution.
Please.
I may be of taking an office.
No, I will.
But I am also devoting my full time to the institution.
Sir,
please mind your words. Please mind your words. And please say.
Control your tongue. I am telling you.
Please use decency while speaking.
I am explaining the. I did not say anything about the SDG has read that. That's the only thing. No. You might be having something in your mind. No. Please don't take that. I am sorry. I did not say anything about this. I only said about the constitution of the EGRC. I only said about declaring the members of the EGRC committee in the council. Why it has not been declared? That is what I am asking. For that, why you take on your path? I did never say that. I didn't say, and I never say anything about the members. These are not the individual members. Sir, this is not the individual members I am talking, it is about the institute, it is about the IEI. I am talking IEI. No personal, in this.
My dear council members, see in sir, Shivanand Roy sir, Shivanand Roy sir, Shivanand Roy sir. No. Yeah. I know that. I know. Sir, let me conclude. आपका हो गया तो just give me a chance to conclude. See, sir, sir, एक minute. Just let me take up the matter. Please.
He was talking to you. You said talk to president. And he was talking to president. If anything you have, you should have talked to president.
See,
he should apologize.
Okay,
for the,
now. Yes, sir. 100%. नहीं सर AGM है, ये मेंबर्स के लिए है और मेंबर्स का भी सुना जाएगा 100%. नहीं अंदर से कुछ नहीं होगा, सब मेंबर्स को दिखा के ही होगा और मेंबर्स को पूछ के ही होगा. But see, very well noted, few points I have already noted that your point was also valid that the EGRC committee should have been circulated, so I'll take care of that. I assure on behalf of SDG that whatever the committee is being constituted, it will be mailed to all the council members whenever it is formed. So please, Ramna Naik sir, 1 minute. And the other also, the points which all the members have said, I have also noted that. But see, regarding this EGRC, why it has not been given, so I think it has been given to the complainant who has done the complaint. So it has sent to me, as per my knowledge, I don't know. Let me go through the documents if provided to me. I'll go through that documents. Rightly you said that whether it is fabricated, whatever it may be, whatever. So let us go through the documents. It will be open and I'll go through it. And then when the appeal comes, whatever it is under the bylaws, whatever it is under the regulations, whether it is observed or not, for the election procedure, I'll go through it, I'll discuss it, and then I'll take the proper decision which will be non-biased and which will be under our rules and regulations and the bylaws. I assure that nothing wrong will be done, nothing unless out of the bylaws will be done, out of regulations will be done. And one agenda is there. Sir, Sir, let me, Kurupaswamy, sir, yeah. No, sir. Thank you. Thank you so much. Thank you so much. So I'll assure that it will be everything as per the bylaws and regulations. I'll go through it. Whatever it is there, I'll go through it. I assure you. We'll go to the next point of the agenda. To point. Take care. Take care.
With the permission of sir, with the permission of president, sir, with the permission of president, sir, 1 minute, sir, it'll get over. It'll get over. With the kind permission of president, it was never my intention to tell. And sir, please, 1 minute.
Sir, your feelings, Shama Pradar Reddy sir's feelings are very well taken. So your feelings are very well taken.
Sir, it is never my intention. Satyanarayana and Garu and me are of this thing. We are very good friends. And it is never my intention to tell anything wrong to him. And if it has been felt by Satyanarayana sir, I don't talk with others. If Satyanarayana sir has felt anything wrong in that, I am sorry.
Thank you. Thank you, council members. Thank you, SG sir. We will go for the next point of the agenda, item number 4, to appoint the auditors for the year 2025-26 and fix their remuneration. I'll come to this thing. Auditors, Mr. D.K. Chartered and Company, Chartered Accountants may be appointed for the year 2025-26 at the remuneration of rupees 3 lakhs. Nothing has been increased as per the old remuneration. Approved? Thank you. Thank you so much. So friends, by this the agenda is over, and I thank you all for participating in this annual general meeting, and I now declare that the meeting has closed and request all of you to stand up for the national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तव शुभ नाम जागे तब शुभ आशीष मांगे गाएं सब यह गाथा जन गण मंगल नायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे। All corporate members are requested to please come for the valedictory session. Same location, sir, as the inaugural session and memorial lectures. Main hall. Sorry. Please stay back for the valedictory session. Sir, it is here only. Photographers को बुलाओ.
कांबळे सर शांतिमय महाराष्ट्र बाद में होना चाहिए भाई, महाराष्ट्र बाद में। महाराष्ट्र लगा
Hello. For today's validity session, our chief guest and guest of honor already arrived here. So shortly we are starting the validity session. All are requested to please be seated so that we can start the validation in time. Respected sirs, it is for your kind attention. Respected sir, our today's validation session chief guest and guest of honor already arrived in the hall. All are requested to take their respective seats so that we can start our program on time.
आपला मोबाईल कोणातरी द्या नाही तर कॅमेरावाल्यालाच द्या.
Ladies and gentlemen, we ardently request you to kindly take your seats in the Great Hall. We shall begin with the valedictory session. We sincerely thank all the members of the Institution of Engineers for felicitating President Kothari sir. However, unfortunately, we regrettably ardently request you to kindly take your place in the audience. We are going to start our valedictory session. Ladies and gentlemen, we are going to begin with the valedictory session, and with that, it will bring us to a close of this 3-day 40th Indian Engineering Congress. We request all the participants of the 40th Indian Engineering Congress to kindly take their place in the audience. We are going to begin with the valedictory session shortly.
গ্লিমসেস অফ ইঞ্জিনিয়ারিং পার্সোনালিটিটা দেওয়া হবে।
স্যার তো একজনই আজকে।
হ্যাঁ, ওকে।
Ladies and gentlemen, we are starting with the valedictory session, and before we begin with the valedictory session, I am very honored to invite you to the final session of the 2-day 40th Indian Engineering Congress held here in NIT Durgapur, hosted by Durgapur Local Center of the Institution of Engineers, India. Yesterday, we could not complete our glimpses of engineering personalities. And however, even though we could not complete it, we are very proud to announce that we have received one of our most eminent personalities here today. And I am very proud to invite to the dais Mr. Shurujit Mishra, Director in charge of DSP and ISP SAIL. I invite on the dais Mr. Shurujit Mishra, sir. And I request our President, M.M. Kothari sir, Engineer Manish Mahendra Kothari sir, for very kindly welcoming on the dais Mr. Shurujit Mishra, Director in charge of DSP and ISP SAIL. Ladies and gentlemen, we also want to invite on the dais Mr. Pranab Kumar Ghosh, Managing Director of SBSTC. We are incredibly honored that both Mr. Ghosh and Mr. Mishra have joined us here on the dais. Our chief guest of the day, Mr. Shurujit Mishra, we could not have him here yesterday. However, his presence here right now brings us immense honor. I invite our President, Engineer Manish Mahendra Kothari sir, to kindly deliver the welcome address.
तो हाँ दे दो अभी बट ये अभी मैं वेलकम करके फिर दे दूँ इसको वेलकम कर लीजिए फिर वो अनाउंस कर देंगे Good afternoon, everybody. Good evening, okay? Okay, sorry. Good evening, everybody. Dignitaries on the dais. Mishra sir, Ghosh sir, immediate past President VP Singh sir, Congress Organizing Chairman Shafiqul Bhai, Vimal Das. Nevertheless, my dear all brothers and sisters of the council members. Friends, we have come to an validatory or the concluding session of the 3 days Congress, which is held at the Durgapur under the slogan of Innovative Engineering Solutions for Vikasit Bharat. It gives me immense pleasure and deep sense of fulfillment to address you the validatory session for the 40th Indian Engineering Congress being held during the 19th to 21st December 25 under the inspiring theme Innovative Engineering Solutions for Vikasit Bharat. The Indian Engineering Congress is not merely an annual event of the Institution of Engineers. It is the continuing national dialogue on the role of engineering in shaping India's destiny since its inception in 1987. The IEC has evolved into the prestigious platform where policies, practice, research and innovations covers the 40th edition stands as a significant milestone. In this long journey, reaffirming IEI's commitment to the engineering excellence, national development and global engagement. This Congress was graciously hosted by the Durgapur Local Center with National Institute of Technology Durgapur as a knowledge partner and SAIL, Durgapur Steel Plant as the industry partner. I place on record my sincere appreciation for their exemplary support and cooperations which have contributed immensely to the smooth conduct and high academic standards of this Congress. Friends, I believe that when academia and industry fraternity come together, we can achieve many things. Over the past 3 days, the Congress has witnessed a rich and carefully curated program blending traditions with contemporary relevance. An inaugural day commenced with the Industry Excellence Award, Engineering Education Excellence Award, National Design Award, and the institutional prizes, recognizing outstanding contributions by industry institutions and individuals who continue to raise the bar and engineering practice education in the country. The second and the third day of the Congress were marked by the technical session spread over 2 days
integrated with memorial lectures instituted by memory of the same of the most distinguished engineers of our nation. This includes Sri Mokshagandham Vishweshwaraya's Memorial Lecture, Sri Rajendranath Mukherjee Memorial Lecture, Nidhu Bhushan Memorial Lecture, Baikaka Memorial Lecture, Dr. Ajudhya Khosla Memorial Lecture, Dr. Amitabh Bhattacharya Memorial Lecture, Professor C.S. Jha Memorial Lecture, and others. Each of these lectures was delivered by the eminent personalities from industry, academia, and public services, and provide deep insights into the hardship infrastructure, development innovation, sustainability, and nation building. In addition of this, prestigious lectures of Congress featured glimpses of engineering personalities, women engineers meet, III alumni meet, and the vibrant technical exhibitions which together enrich the Congress by promoting integrity, global interactions, mentorship, and industry academia linkage. A major intellectual pillar of this Congress has been the technical paper presentations based on the technical session scheduled. The Congress successfully conducted 5 major technical sessions across 2 days, comprising multiple parallel tracks. More than 200 technical papers were presented through oral and poster sessions. Covering almost all the III's engineering divisions, these papers addressed cutting-edge themes such as smart infrastructure, advanced manufacturing, renewable energy, artificial intelligence, robotics and automations, material for strategic sectors, environment, sustainability, biotechnology, aerospace systems, textile innovation, and digital transformation. The diversity and depth of these presentations clearly reflect the vibrancy of the Indian engineering research ecosystem. The active participations of faculty members, researchers, industry professionals, and students has ensured meaningful discussion and the feedback. I am particularly encouraged by the enthusiastic participation of the young engineers and students. Their ideas, questions, and innovations resources that the future of Indian engineering is in capable, creative hands. The recognition accorded today to the student chapter for outstanding enrollment is a testimony of IEI. I am pleased to note that during the validatory sessions, we have also marked the release of the annual technical volumes of the various engineering divisions of the Institution of Engineers. This volume prepared with academic rigor and professional insights, capture contemporary research, case studies, and technological advancement. The theme of the Congress, Innovative Engineering Solutions for Vikasit Bharat 2047, has resonated strongly across all sessions. As India approaches the century of the independence, engineering will play a decisive role in achieving sustainable infrastructure, energy security, digital sovereignty. The deliberations of this Congress have clearly underlined that innovations, ethics, professionalism, and collaborations must remain in the constant of hour. As we conclude, let us carry forward the ideas, insight, and inspiration gained here into our workplaces, institutions, and communities. Let this Congress not be seen as an end, but as a renewed beginning, a renewed commitment to engineering excellence in service to the nation. Friends, I once again thank you all the delegates, speakers, organizing partners, and volunteers for their invaluable contribution, and I wish you all a continued success in your professional endeavor. Once again, friends, I wish you all upcoming Happy New Year, and thank you for the patience listening. Thank you very much. Jai Hind.
Thank you, sir. Ladies and gentlemen, please now allow me to invite to the dais our past President G. Rangnath, sir. So please kindly grace us with your presence on the dais. Ladies and gentlemen, a big round of applause, please, for our past President, Engineer G. Rangnath, sir. With that, I am now going to request Engineer Manish Mahendra Kothari, sir, President of IAI, for very kindly, so we request you to felicitate our chief guest, Mr. Shurujit Mishra, sir, Director in charge of DSP and ISP SAIL. Ladies and gentlemen, we sincerely thank Engineer Manish Mahendra Kothari sir, and now we request you again sir to kindly felicitate our guest of honor Mr. Ghosh. Mr. Ghosh is the Managing Director of SBSTC. I request the team member of the organizing committee to kindly present a bouquet of flowers, and we request Engineer M.M. Kothari sir to kindly present our guest of honor Mr. Pranab Kumar Ghosh, Managing Director of SBSTC, with a bouquet of flowers to warmly welcome him amongst us here to the valedictory session of the 3-day 40th Indian Engineering Congress. Sincerely thank you, sir. Ladies and gentlemen, we now request Engineer M.M. Kothari sir, President of IAI, to kindly read the glimpses in honor of our chief guest, Mr. Shurajit Mishra sir.
Under the thing of glimpses of engineering personality, one of us is an towering personality, Mr. Surojit Mishra. Sir, I take this privilege to read your glimpses. Distinguished delegates, past presidents, vice presidents, members of my council, corporate members, ladies and gentlemen. The role of engineers in driving industrial growth and sustaining core manufacturing sectors has been both profound and enduring. Upholding this legacy, the Institution of Engineers India organizes this annual session to acknowledge engineering leaders whose operational excellence and stewardship have enhanced the motion industry capacity. It is an honor for us to interact with such an eminent professional and benefit from his insights. We have with us today Mr. Surojit Mishra, Director in charge, ISP and DSP, Steel Authority of India Limited, Cell. I now request the Shafiqul Islam sir to formally present these glimpses.
Ladies and gentlemen, please allow us now to kindly felicitate Mr. Shurajit Mishra, our chief guest, the Director in charge of DSP and ISP of SAIL. I request the team member of the organizing committee to kindly help our past president and also President Sir of IAI, and we request both of them to very kindly felicitate our chief guest of the day, Mr. Shurajit Mishra. Ladies and gentlemen, Mr. Shurajit Mishra unfortunately could not join us yesterday. However, we are extremely honored that he could find the time and accommodate the 40th Indian Engineering Congress on the final day of this grand event. I thank our President Sir, also our past presidents, for very kindly giving out the felicitation items, and we are incredibly honored that they made the time for us here. Ladies and gentlemen, we are now very proud to move on with the valedictory session. I would like to request ladies and gentlemen, I would now like to move on with the valedictory session, and once more I request all of you to warmly welcome amongst us once more our chief guest and guest of honor here to the final session of the 3-day 40th Indian Engineering Congress. Ladies and gentlemen, we welcomed on stage our guest of honor, Mr. Pranab Kumar Ghosh, Managing Director of SBSTC, as our guest of honor, absolutely. And we also welcomed our chief guest, Mr. Shurajit Mishra, Director in charge of DSP and ISP, SAIL. However, I would like to take this opportunity to once again present some very small tokens of gratitude on behalf of the Institution of Engineers India, once again to our esteemed chief guest and guest of honor. I request Engineer Manish Mahendra Kothari sir to kindly present the token of gratitude on behalf of the members of the Institution of Engineers India. We first of all would like to request Mishra sir to very kindly accept the small token of gratitude on behalf of IEI We request our President Kothari sir, Engineer Kothari, and we thank him for felicitating our chief guest. We shall now request Kothari sir to felicitate and grant upon him Mr. Pranab Kumar Ghosh, Managing Director of SBSTC, the plaque of honor for being such a vital part of the 40th Indian Engineering Congress. Ladies and gentlemen, we are extremely honored that they made time for us, and we are also extremely thankful that the grand session, the sessions of the 40th Indian Engineering Congress are coming to a very beautiful close. Ladies and gentlemen, please now allow me to invite Engineer Safiqul Islam, Chairman of the Organizing Committee of the 40th Indian Engineering Congress, and we request him to deliver the welcome address for this valedictory session.
Thank you, ma'am. Respected dignitaries on and off the dais, respected President of the Institution of Engineers, India, respected immediate past presidents and past presidents of IEI, esteemed council members, eminent dignitaries from industry and academia, distinguished delegates, ladies and gentlemen. A very good afternoon to all of you. Today marks the valedictory and concluding session of the 40th Indian Engineering Congress, and it is indeed a moment of pride, fulfillment and reflection for all of us who have been part of this prestigious national event. Over the last 3 days, from 19th to 21st December 2025, this Congress, organized by the Institution of Engineers India and graciously hosted by the Durgapur Local Center at the National Institute of Technology, Durgapur, has successfully showcased the intellect, innovations and integrity of the Indian engineering fraternity. The Congress commenced on 19th December 2025 with the Industrial Excellence Award function, recognizing outstanding contributions to industry. This was followed by the series of distinguished award ceremonies, including Safety and Quality Awards and the National Design Awards. These honors not only celebrated excellence but also reinforced our collective commitment to quality, safety, sustainability and innovation during 20th and 21st. We are privileged to witness inspiring moments during the inaugural session, enriched by glimpses of engineering personality awards and a series of prestigious memorial lectures delivered by eminent personalities whose wisdom and experience have left a lasting impression on all delegates. One of the remarkable achievements of this Congress has been the presentation of more than 200 technical papers reflecting cutting-edge research, practical insights, and forward-looking solutions across diverse domains of engineering. The deliberation, discussions, and exchanges during technical sessions have undoubtedly contributed to knowledge enrichment of professional growth. On this auspicious concluding day, it gives me immense pleasure to inform you that we are honored by the gracious presence of our distinguished guests. Respected Sri Surojit Mishra sir, Director in Charge, DSP and ISP Cell, as the chief guest of today's valedictory session, and respected Sri Pranab Kumar Ghosh sir, Managing Director, South Bengal State Transport Corporation, as the guest of honor. May I request everyone to join me in welcoming our esteemed distinguished with warm applause, round of applause. I would like to place on record our deep appreciation and heartfelt gratitude to the National Institute of Technology, Durgapur, and also the Durgapur Steel Plant for their wholehearted support, cooperation, and hospitality. Their commitment and meticulous arrangements the arrangements of the NIT have enabled us to organize the 40th Indian Engineering Congress in a befitting and memorable manner, befitting in national structure. As we conclude this grand congress, let us carry forward to spirit of innovation and ethical engineering and societal responsibility that the respondent through every session of these 3 enriching days. May the bond forged here translate into collaborations, ideas into actions, and visions into reality for the progress of our nation. With these words, I thank each one of you, our dignitaries, delegates, organizers, volunteers, and participants for your valuable contribution to the success of this historic event. Thank you all. Jai Hind.
We sincerely thank Engineer Safiqul Islam for delivering the welcome address to everyone here present in the Great Hall to this valedictory session. I shall now request Dr. Arup Kumar Mondol, convener of the Organizing Committee of the 40th Indian Engineering Congress, to kindly deliver the reporting of this Congress. Sir, please.
Thank you. A respected chief guest, Surajit sir, respected President Pranav sir, President of IEI, President-elect IEI, Chairman of 40th IEC, Chairman Durgapur Local Center, and Secretary Durgapur Local Center. Honorable dignitaries, esteemed delegates, ladies and gentlemen. Good evening. It is my honor and privilege to present the final reporters report of the 40th Indian Engineering Congress held from 19th to 21st December 2025 at the National Institute of Technology, Durgapur, under the aegis of the Institution of Engineers, India. The Congress brought together engineers, academicians, researchers, industry professionals, and students from across the India, providing a vibrant platform for the exchange of knowledge, ideas, and best practices across diverse engineering disciplines. The deliberations were closely aligned with the national vision and of Viksit Bharat at 2047, emphasizing self-reliance, sustainability, innovation, and technological advancement. The Congress commenced on 19th December 2025 with the IEI Excellence Award function, held at this NIT Durgapur campus at room number 401. The function was graced by Sri Pranav Kumar Ghosh, WBCS Executive Chairman and Managing Director of South Bengal State Transport Corporation, as a chief guest, and Professor Arvind Choube, the Director of National Institute of Technology, Durgapur, as guest of honor. The inaugural function of the Congress was held on 20th December 2025 and was marked by the lighting of the ceremonial lamp, followed by welcome address and inspiring speeches by eminent dignitaries from government, industry, and academia. Important publications, including technical volume of the Congress, Obhijanta Bandhu, and souvenir were released, reinforcing IIA's commitment to knowledge dissemination. A special session titled Glimpses of Engineering Personalities, held on the same day, featured distinguished leaders including Dr. Ajay Kumar, Chairman UPSC, Mr. Sanjay C. Kirloskar, Chairman and Managing Director, Kirloskar Brothers Limited, Lieutenant General Rajiv Kumar Sahani, AVSM, VSM, Mr. Satish Jha, CMD, Eastern Coalfields Limited, Professor Sudhanshu Shekhar Chakraborty, Dr. Sandeep Shangal, Managing Director of UJVN Limited, and today Mr. Surajit Mishra, Director in charge, Cell, and Professor Arvind Chobe, Director of NIT Durgapur, was received this eminent glimpses of engineering personalities award. The major highlight of the Congress was the series of prestigious memorial lectures delivered by eminent experts. This included 68th Sir Vishwaswaraya Memorial Lecture by Engineer M. Kishore Kumar, the 51 Baikaka Memorial Lecture by Mr. Sanjeev Singh, 38th Dr. N. Khosla Memorial Lecture by Professor Tapos Chakraborty, 47th Sir R.N. Mukherjee Memorial Lecture by Mr. Akhil Gupta, and 15th Professor C.S. Jha Memorial Lecture by Mr. Praveen Kumar. These lectures provided valuable insights into the infrastructure development, industrial leadership, and future roadmap of engineering in India. The technical program of the Congress was extensive and well structured. Papers were invited from 15 engineering disciplines. An overwhelming response was received with nearly 300 papers submitted, of which 276 papers were accepted for rigorous peer review for oral and poster presentation. These papers were presented through 32 oral sessions and 1 poster session over the 2 days. Due to the cancellation of Indigo flights and several requests we have received from the authors to conduct their paper in online mode. Therefore, 2 dedicated online sessions, technical sessions, were specially organized, enabling the presentation of 28 papers and ensuring continuity of the academic deliberations throughout without compromising the quality. Across all sessions, strong emphasis was placed on emerging areas such as artificial intelligence, digital transformation, India 4.0, renewable and clean energy, sustainable infrastructure, automation, climate reliance development. The poster session, along with special programs such as Women Engineers Meet, Annual General Meeting of India, IEI, added significant value by promoting inclusivity, leadership, and professional networking. In conclusion, the 40th Indian Engineering Congress successfully achieved its objective of knowledge sharing, professional interaction, and vision building. The Congress reaffirmed the pivotal role of engineering in national development and in shaping a sustainable and technologically advanced future for India. I express my sincere gratitude to the Institution of Engineers India, NIT Durgapur, the Durgapur Local Center, the organizing committee, session chair, reviewers, volunteers, and all participants for their dedicated efforts in making this Congress a grand success. Thank you. Jai Hind.
Thank you, Dr. Arup Mondal, sir, the convener of the organizing committee of the 40th Indian Engineering Congress, for delivering that comprehensive report on this Congress, the 40th Indian Engineering Congress. Ladies and gentlemen, at this moment, it is my privilege to invite Engineer V.B. Singh, immediate past president of the Institution of Engineers India, to very kindly introduce the president of IAI, Engineer Manish Mahendra Kothari. Ladies and gentlemen, we welcome
Honorable Chief Guest, Mr. Surajit Mishra ji, Director in Charge, DSP, ASP, ISPL of SAIL. Guest of Honor, Mr. P.K. Ghosh, who is Managing Director of South Bengal State Transport Corporation. My President, Mr. Manish Kothari, past president, all the past presidents, and organizing chairman, Mr. Safiqul, and chairman of the state center, Mr. Professor Chandan Konar, my council colleagues, corporate members, ladies and gentlemen, a very good evening to all of you. It is my proud privilege to introduce to this August gathering Mr. Manish Mahendra Kothari, President of the Institution of Engineers for the session 2025-26. Mr. Kothari is a fellow of the Institution of Engineers and a chartered engineer with over 3 decades of professional experience. As an engineer, industrialist, and institutional leader, he holds a bachelor's degree in mechanical engineering from Pune University and an advanced diploma in industrial safety, and is also a government-approved valuer, certified safety auditor, and authorized competent person under the Factories Act. He is the director of Maharashtra Pipes and Allied Industries, Nashik, an ancillary unit of Hindustan Aeronautics Limited, engaged in the manufacture of ground support equipment and precision components for the Indian Air Force. His professional career reflects a strong commitment to quality, safety, and indigenous manufacturing. Mr. Kothari's association with Institution of Engineers spans more than 30 years. Beginning as a corporate member in 1995, he has served the institution at both center and national level, including as chairman and member of the key committees such as Finance Committee, Membership Committee. His contribution have been instrumental in strengthening financial governance and introducing digital reforms. Notably among them is online membership application system. Beyond Institution of Engineers, he has also played an important role in industrial development as chairman of the Nashik Engineering Cluster and as president of Nashik Industrial Manufacturers Association, working closely with MSME and industry stakeholders. With his balanced perspective of industry, profession, and institution building, Mr. Kothari brings a clear and forward-looking vision to the Institution of Engineers. I have now honor to I think you have already spoken. Again, no problem. Speak for few. Now, I now have honor to invite Mr. Manish Mahendra Kothari, President, II, to address the gathering. Say a few words.
Ladies and gentlemen, we have the honor of listening from Engineer M.M. Kothari, sir.
Thank you, V.V. Singh sir, for an brief and beautiful introduction. Dignitaries on the dais, fellow industrialist, V.V. Singh sir, Ranganath sir, Shafiqul bhai, Konar, and my dear council members. Again, as an president, I will like to say a few things which I was regarding the Congress, the papers which we present and the technical inputs we get. But I am of the opinion, or we will try, that next time we will start with some of the hackathons and the startup competitions, so that the ideas will be converted into actual thing, and we will help them. Our technical stalwarts are here, so many stalwarts, 95, 100 stalwarts are here. We will help them to grow, to convert their ideas into the business, and I assure that through different authorities which I know where the fundings can be done. I assure that I am the chairman of the Nashik Engineering Cluster, the only cluster in India successfully running under the DIPP project of Prime Minister, and having the funds, allotted funds to distribute 4 crore rupees a month to the startups. So I will take this opportunity in grooming and helping the new startups to grow. We will together help them to technically grow and see that new entrepreneurs are grown under our umbrella of the Institution of Engineers, so that the Institution of Engineers, the prime and the most biggest body in India, will have a different role to play. I also have a confidence, Mishra sir and Ghosh sir is there. They will also help us in this endeavor of the new coming. Once again, friends, thank you for your patience hearing for a few moments. Thank you. Thank you so much. Jai Hind.
Thank you, sir, for that inspiring address, and we look forward to your leadership. And now, ladies and gentlemen, we proceed to an important segment of the valedictory session. I would like to request all our dignitaries on the dais to kindly participate in the release of the annual technical volumes. I request the team members of the organizing committee to help our dignitaries release the annual technical volumes of the following engineering division boards. Please allow me to introduce the names of the division boards: Architectural Engineering Division Board, Civil Engineering Division Board, Chemical Engineering Division Board, Environmental Engineering Division Board, Electrical Engineering Division Board, Mechanical Engineering Division Board, Metallurgical and Materials Engineering Division Board, Electronics and Telecommunication Engineering Division Board, Production Engineering Division Board, Textile Engineering Division Board, and Interdisciplinary Coordination Committee. Ladies and gentlemen, all these technical volumes are being released by the dignitaries on the dais right now in the valedictory session of the 40th Indian Engineering Congress. Presentation of letters of appreciation to the IEI students, chapters. Ladies and gentlemen, with that, we'll move on to the next important segment, and that is the presentation of letters of appreciation to IEI students chapters for achieving the highest enrollment of student numbers. Ladies and gentlemen, this is a very important segment because as we welcome new members into IEI, we also invite new ideas, new members not only, but also we encourage new concepts, new mindsets. I request, ladies and gentlemen, please allow me to read this out. As decided by the Council, the Institution of Engineers India has launched Certificate of Appreciation for Students chapters in engineering colleges and in polytechnics for the highest enrollment of students in their respective chapters. I am going to announce the names of the chapters. Certificate of Appreciation for Students chapter in Engineering College at Northern Zone for 2024-25 goes to Department of Computer Science and Engineering of Jodhpur Institute of Engineering and Technology, Jodhpur. Ladies and gentlemen, there is no one from Jodhpur Institute at the moment, probably. The next Certificate of Appreciation for Students chapters in Polytechnic at Northern Zone for 24-25 goes to Kamla Nehru Institute of Physical and Social Sciences, Engineering Institute of Sultanpur, Uttar Pradesh. Certificate of Appreciation for Students chapters in Engineering College at Eastern Zone for 24-25 goes to Department of Civil Engineering, the Assam Royal Global University, Guwahati. Certificate of Appreciation for Students chapters in Polytechnic at Eastern Zone for 24-25 goes to New Government Polytechnic, Vaishali, Bihar. Certificate of Appreciation for Students chapters in Engineering Colleges at Western Zone for 24-25 goes to Department of Artificial Intelligence and Data Science, P.R. Pote Patil College of Engineering and Management, Amaravati. Certificate of Appreciation for Students chapters in Polytechnic at Western Zone for 24-25 goes to Government Polytechnic, Amravati. Certificate of Appreciation for Students chapters in Engineering College at Southern Zone for 24-25 goes to Department of Electronics and Communication Engineering, Sheshadri Rao Gudla Velaru Engineering College, Andhra Pradesh. And ladies and gentlemen, please allow me to introduce the final certificate of appreciation for students chapter in Polytechnic at Southern Zone for 24-25 goes to Thiagarajar Polytechnic College of Salem. Ladies and gentlemen, we have now come to the end of the valedictory session of the 40th Indian Engineering Congress. And to usher in the conclusion of this grand event, I would like to request Dr. Bimal Das, Honorary Secretary of IEI Durgapur Local Center, to kindly propose the final vote of thanks. Sorry, sir, I request...
Sorry for the interruption. So, before the vote of thanks, I would like our new elected president, sir, to hand over a token of appreciation to our Professor Diya Bandyopadhyay ma'am, because her contribution is not be expressed in words. Throughout the session and for 3 days, he did her best for the Institution of Engineers, and we are very much grateful to her for his great contribution. And I request our President, sir, please hand over that token of appreciation to Professor Diya Bandyopadhyay. Please. Thank you, sir. Please continue.
Ladies and gentlemen, I sincerely thank you everyone for all the compliments that I have gotten in the past 3 days. And with that, I would now like to request Dr. Bimal Das, Honorary Secretary of IEI Durgapur Local Center, to kindly propose the final vote of thanks.
Friends, we have got two towering personalities with us. And if they don't give their glimpses of the views which will guide us and which will encourage us, so I'll request first Mishra sir to please deliver the few glimpses of the guidance for his entire experience of so many years in the cell. So please.
Dignitaries on the dais, dignitary of the dais, and council members, and all the honored, experienced engineers that I see before myself. From a humble member of Indian Institution of Engineers, my salutations to all of you. And first of all, let me congratulate Kothari Sahab for having taken over as the president of our Institution of Engineers. I call it ours because I am also a small member. Having passed out of engineering college with an electrical engineering graduate degree, I joined SAIL, and it has been a long journey for me. From a person who joined a blast furnace project, it was India's first in-house built blast furnace. SAIL had designed its own blast furnace for the first time. It was a small blast furnace, but it was SAIL's own. And I was part of that team that built that blast furnace. And here again at Durgapur, at ISP, we are building one of the largest blast furnaces in the country. At Durgapur also we are building 2 new blast furnaces. All my life I have been a steel man. And SAIL takes particular pride in, जैसे कोठारी साहब ने कहा कि we have to encourage our MSMEs, we have to encourage our startups. SAIL already has very strict policies to encourage startups and MSMEs. Certain categories of products that we procure to the tune of approximately 50 crores, we procure only from MSMEs. Those products can be purchased only from MSMEs. We have reserved certain products which we procure only from MSMEs as a matter of policy. For startups also we have a policy. Say, for example, when we evaluate our tenders, we have some pre-qualification that suppose the tender is of a value of 10 crores, then he should have executed an order of at least 3 to 4 crores. But when it comes to a startup, we waive those criteria. The idea is that we understand that they may not have any pre-qualification, So we weigh up those criteria so that we encourage startups, because that is where the future of our country lies. If I have traveled extensively in Europe, and the European companies that are world leaders today, whether it is we take Rexroth or Bonfiglioli or Cert Metal and all those companies, they started out as startups, family startups in fact. Somebody invented something, somebody developed something and started a small company, and those companies have now become world leader. When we talk of hydraulics, we talk only Rexroth. And Rexroth still continues to be owned by a small family, whether it is Bonfiglioli or the engineering goods that, because those are the things I am familiar with. So my dream is that to see India at that level where our startups become world leaders, having developed some, having excelled in certain products. It is not that all European companies have become like Siemens or ABB, large conglomerates. There are many small European companies who are the best in what they do. When we talk of a hydraulic cylinder, we talk of Hunger. When we talk of hydraulic seals, we talk of Hunger. And Hunger is a small family-owned company managed by brother and sister. In fact, I have met the managing director, who is a lady. She runs the company. Her father was a blacksmith. He used to salvage some, during Second World War, the Russian planes that had fallen off. He used to collect the hydraulic cylinders and fit them into tractors. That is how that Hunger Hydraulics company started. And now it is the world leader in hydraulics. So, for experienced engineers like us, we have to pass on our baton to the new generation, and the dream still remains that we will see an India where these startups will make world-beating products. They may be in any particular field, but they will be world-beating. And I can say from my experience of in the industry that we have many such pioneers. There's Lotus Wireless. It was a small company once. We used to promote them for wireless automation. Now they are world leaders. Say in certain technologies, we prefer them even to Siemens and others. Certain wireless automation technologies, every industry, not only we at SAIL, even private industries, they are preferable to. They do a better job than even Siemens because they focus on that particular sphere of excellence. Not only Lotus Wireless, there are many such companies who have become pioneers in their own field. So it is our job, being a government organization, we are closely aligned with the dreams of the government, of the aspirations of the government to make our country a developed one by 2047. So we are closely aligned with the aspirations and visions of the government, and we are hand in hand with that. We promote MSMEs, we promote industry academia partnerships, and we also promote startups. About industry academia partnership, let me be very honest that we have not gone very far in that direction, although in spite of our attempts, we have not gone very far in that direction. A lot of things needs to be done in that area. Although with startups, the ecosystem has been very encouraging. Although our most successful startups are not exactly in the field of engineering excellence, but almost all of us are aware that many startups are coming up. Although our most successful startups are only in the field of logistics or distribution channeling, but some startups are there who have been doing excellent work in the field of engineering and manufacturing. Let us encourage all of them as experienced engineers. Let us do the handholding that they require. Probably as a government company, of course we do. I request that all of us as experienced engineers, we have to do a bit of handholding for them. And also to our students, they need training, they need our help to come up. I don't think I have much more to say. It's already late in the evening. Thank you very much. And it is a matter of great pride and honor for me to have received that award for Glimpses of Engineering Excellence. Thank you. Thank you in the institution of me.
We sincerely thank Mr. Shurajit Mishra, Director in charge of DSP and ISP SAIL, for kindly addressing the audience here in this hall. I shall now request Mr. Pranab Kumar Ghosh, Managing Director of SBSDC, to kindly address us one last time. Sir, please. A few words. Sir, a few words, sir.
Good evening to all. I will not take much time. We are in the last part. Our respected chief guest on the dais, respected other dignitaries, President IEI, past presidents, respected chairman of the organizing committee, respected convener of the organizing committee, and all respected dignitaries on and off the dais. This is a proud moment for all of us to address the program. I came to this program in the first day itself, and I spoke few words. I hope the 3-day conference, that is on innovative engineering solution for Viksit Bharat 2047, has organized in a beautiful coordinated approach, and IEI Durgapur local center has organized it very successfully in the campus of National Institute of Technology Durgapur with the industry partner SAIL, Steel Authority of India Limited. We all know that to organize such a big event in the small town Durgapur was a challenge for them, but we hope that they will. This program was very successful, and in the future also they will organize very beautiful event. And this is a different participants who are present here. They have also enjoyed different sessions, and they also enjoyed their stay in Durgapur. We believe they have enjoyed their stay here. And I would not say much more on the issues. This is just concluding part. Thanks to all. Jai Hind.
Ladies and gentlemen, we sincerely thank Mr. Pranab Kumar Ghosh, Managing Director of SBSTC. And now, a few congratulations are in order. And to announce the same, I would like to request Professor Dr. Sushmita Datta, Chairman of the Technical Committee of this 40th Indian Engineering Congress. I would request her to please come up on the dais and announce the Best Paper Awards. Ma'am, please.
Hello. Good afternoon. On behalf of Technical Committee, I thank you all for active participation in 40th Indian Engineering Congress 2025. We invited papers from 15 disciplines. They are aerospace engineering, industrial and production engineering, environmental engineering, agriculture engineering, biotechnology or biomedical engineering, chemical engineering, civil engineering, electrical engineering, electronics and communication engineering, computer science and engineering, instrumentation engineering, robotics and automation, textile engineering, metallurgical and material engineering, last mechanical engineering. We have got an overwhelming response, and for this we extended the deadline for paper submission a number of times, and we received about 300 papers. And after reviewing, we accepted 276 papers either for oral presentation or poster presentation. The statistics are as follows. The aerospace engineering, we have got 8 oral papers and 1 poster, total 9. Industrial and production engineering, for oral presentation 7 papers, for poster 1, total 8. Environmental engineering total oral presentation 15, and for poster 2 total 17. Agricultural engineering 4 papers and poster 1 total 5. Biotechnology 10 papers for oral presentation, for poster it is 2 total 12. Chemical engineering 22 for oral presentation, no poster presentation, so total 22. Civil engineering 33 for oral presentation and 5 poster. And then electrical engineering 24 for oral presentation, 1 poster, total 25. Electronics and communication engineering 19 papers, no poster presentation, total 19. Computer science and engineering 39 papers we have obtained, 5 poster, total 44. Instrumentation engineering 2 total. Robotics and automation 5 oral presentation, no poster, total 5. Textile 7 oral presentation, no poster, total 7. Metallurgical and material engineering, that is 3 for oral presentation, 22 for oral presentation, 3 for poster, total 25. And mechanical engineering 33 oral presentation and 5 poster presentation, total 38, total 276. Now based on the subtopic of each disciplines, papers were presented in 32 oral sessions and 1 poster session. And however, due to problem in aviation field, we received a number of requests from authors for online presentation, and 2 online sessions were arranged, and total number of online presentations were 23, and we have total 115 papers have been presented either oral or poster. So and now I am telling the name of the best. We have given the best paper based on the discipline. Whatever number of papers were there, but based on the discipline, we are selecting the awardee. And for poster, we have selected 2. But in some discipline, we have got the 2 marks, same 2 marks. So we have selected those persons. So for industrial and production engineering, paper ID 288. The AI-enabled predictive modeling and GA optimization for sustainable electric arc furnace, NIT Durgapur. This is Narottam Behera and Somashish Saha.
Is the author present here?
Environmental engineering, 2 papers got the same marks. Oxidation and biological process, ASP, for the detoxification for the wastewater, Shubhajyoti Sarkar, Rajnarayan Saha, Ganesh Chandra Naik.
Next one.
Paper ID 341.
Please come forward, sir. We request our chief guest, Mr. Shurujit Mishra, and also the President of IAI, Engineer Kothari, to kindly hand over the Best Paper Award to our author. Ladies and gentlemen, a big round of applause, please. We would like to request the author to kindly wait a little for the certificate downstairs after the seminar, after the valedictory session. Kindly collect the certificates which are being prepared right now.
Second, environmental engineering, paper ID 339. Title of the paper is Eco-Friendly Copper Carbon Filtration Technology for Iron Contaminated Groundwater in Rural India, Pubali Dotto. Author Pubali Dotto. Okay. Aerospace engineering, paper ID 235. Unmanned combat UAV design considerations for that one is the Rakesh Kumar Nidhi Barnwan. Anybody? Okay. Then agriculture engineering, paper ID 198, analysis of Pathardi catchment using satellite remote sensing and geographic, Binoy K. Pandey. Binoy K. Pandey. Okay. Then from biotechnology and biomedical engineering, paper ID 218. Title UNET based framework for precise segmentation and diagnosis of cerebral aneurysms. Shagma Rajkumar Deori, Dalam Chami, Chen Ling Do.
The author is here. Requesting our dignitaries on the dais to kindly present the author with this award.
Then next, chemical engineering, paper ID 343, processing wastewater using electrocoagulation and advanced method, comparative analysis of COD and suspended solids removal, Osim Kumar Bhattacharya, Dr. Shailendranath Mondol, Tamal Kanti Das. Okay. Civil engineering, paper ID 185, route to geopolymer concrete, Annamalai University, Nana Sambana. Acha, next, electrical engineering, paper ID 276, the digital phenotyping for rotor fault detection and severity, Lavanya A. Lavanya.
Is the author here? Yes.
EC, Electronics and Communication Engineering, paper ID 291, synthesis using particle swarm optimization and artificial intelligence, Pratap Mojumdar, Sujit Kumar Mondol. Okay. Acha, computer science and engineer.
The author is here.
Computer science and engineering, paper ID 173, attention framework with content aware upsampling for nicotine strain image, Shottanan Goldar, Devobroto Dotto, anybody? Acha, robotics and automation, robot propulsion through Karagi form swimming, model based insights and data analysis, Prashad Binayak Patil. Paper ID
Yes.
261.
Yes.
Division Robotics and Automation. Textile engineering, paper ID 35, upcycling the apparel waste into sustainable composite product A. Textile engineering, Sushma Raut, Anirban Dotto. Anirban. Metallurgical and material science, 270, paper ID 270. It is the footprint framework for steel SMEs in India. This is Rushikesh Mundara, Rushikesh. And another paper ID 234. Mundara. हाँ अच्छा are you ना Another paper 234, process proper. আচ্ছা আচ্ছা আচ্ছা, এখানে যে একটা নাম লেখা আছে 230। Another one, paper ID 234, process property relationship of wire arc additively, Shougato Barik, Manish Kumar Mondol. Shougato Barik, Manish Kumar Mondol from NIT Durgapur. Okay. Mechanical engineering, paper ID 70. It is the vibration control of a machine support concrete structure using model analysis. Shourabh Kongshobonik. Mechanical paper ID 70. Okay, from poster, there is the first and second. The first one is the paper ID 222. It is the influence of surface friction on lift generation and wake dynamics of a rotating cylinder. It is Shahars Gupta. Next, it is the second prize, that paper ID 262, hybrid modeling of transfer bar shape evolution and final strip profile in hot rolling, NIT Durgapur, Arijit Banerjee. Okay, thank you sir, thank you very much.
We sincerely thank Professor Sushmita Datta, Chairman of the Technical Committee, for very kindly announcing the Best Paper Awards, and we sincerely congratulate all the authors who received their awards here today. Ladies and gentlemen, with that, I would again like to invite Dr. Bimal Das, Honorary Secretary of the Durgapur Local Center, IAI, to very kindly deliver the final vote of thanks.
Good evening, all of you. Respected chief guest, honored guest of honor, esteemed dignitaries on the dais, presidents of IEI, and distinguished members of Institution of Engineers, learned memorial lecturers, eminent speakers, delegates, sponsors, members of the organizing committee, ladies and gentlemen. Good afternoon, all of you. So as we are at the end of this program, it is my proud privilege to propose the vote of thanks on behalf of the Institution of Engineers, India, of the 40th Engineering Congress, hosted by Institution of Engineers Durgapur Local Center at NIT Durgapur. We express our deep sense of gratitude of our chief guest at this valedictory session, Mr. Surojit Mishra, Director in Charge, DSP and ISP, SAIL, for gracing this August occasion and for continuous supporting IEI Durgapur Local Center each and every moment. Our thanks goes to our guest of honor, Mr. Pranab Ghosh, MD, SBSTC West Bengal, for his continuous support of Durgapur Local Center. At outset, we express our deep sense of gratitude to our chief guest, Dr. Ajay Kumar, Chairman Union UPSC Commission, for gracing his August occasion and for delivering a highly inspiring inauguration address. His visionary thoughts on governance, leadership, and nation building through engineering excellence have set a meaningful direction of this historic Congress. We extend our sincere thanks to our distinguished guest of honor, Mr. Sanjay C. Kirloskar, Chairman and Managing Director, Kirloskar Brothers Limited, Sri S. Suresh Kumar, IS, Chairman, Damodar Valley Corporation, and Lieutenant General Rajiv Kumar Sahani, Director General, Electronics and Mechanical Engineering, and Colonel Commandant. for their gracious presence and enlightening address, which enlightened the vital role of engineering in industry, infrastructure, energy, defense, and nation development. We place on record our heartfelt appreciation to E.R. V.V. Singh, President IEI, and E.R. Manish Mahendra Kothari, our newly elected President IEI, for their visionary leadership and continuous guidance in strengthening the engineering profession and the institution. We express our deep and sincere gratitude to Major General MGS Saili, our SDG, IEI, for his explanatory leadership, constant encouragement, and able guidance. His dedicated effort in strengthening the academic, professional, and administrative initiative of IEI have been instrument in the successful organization of the 40th Engineering Congress. Our sincere thanks to our due to E.R. Safiqul Islam, Chairman, Organizing Committee, 40th Engineering Congress, for his warm welcome and his outstanding leadership in planning and executive this prestigious Congress. We express our special and thankful gratitude to Professor Arvind Choube, Director, NIT Durgapur, for his invaluable support, encouragement, and guidance. His wholehearted cooperation and instrumental support have played a vital role in making this Congress a grand success. We acknowledge all with deep appreciation all the memorial lecturers for their solitary and thought-provoking lecture, which honored the legacy of eminent engineers and significant enrichment the technical and intellectual content of this Congress. We place on record our appreciation for the dedicated effort of Council of IEI, Advisory Committee, Technical Committee, and Organizing Committee, whose tireless work ensured the smooth conduct of this Congress. Our gratitude also extends to the team involved in the distribution of Institution Prize and Best Center Award and the release of the technical volume of the Congress, Abhijayanta Bandhu, and the souvenir. We placed on record of sincere appreciation all the members of Durgapur local committee of their dedicated efforts, close coordination and support and arrangement and ensuring the smooth conduction of this Congress. We also thank all the eminent speakers, session chairs, panelists, authors, and for their valuable contribution through technical presentation, discussion, and publication. A special, we sincerely thanks our sponsors, partners, exhibitors, and supporters for their generous cooperation and continuous faith in the mission of IEI. A special thanks goes on to volunteers of NIT Durgapur, including faculty members, officers, staffs, and students whose enthusiasm, discipline, and behind of the screen effort ensured this smoothless organization. Finally, we thank all the delegates and participants from across the country and abroad. Their active participation, meaningful interaction, and commitment of the advancement of this engineering profession. I thank all of you. We think we have some disappointment, you have some disappointment in organizing. So we again thank you for all of you for your kind cooperations. Thank you.
Thank you, sir. Ladies and gentlemen, this brings us to a formal conclusion of the valedictory session of the 40th Indian Engineering Congress. Over the past 3 days, the Congress has provided a rich platform of reflection, dialogue, and collaboration and has probably helped. We sincerely hope that there has been some reaffirmation of the pivotal role of engineers in shaping Viksit Bharat, the target of 2047, through innovation, integrity, and professional excellence. On behalf of the Institution of Engineers India, I extend our sincere gratitude to the chief guests, the guests of honor, our distinguished dignitaries, speakers, delegates, sponsors, partners, and the members of the organizing and technical committees whose collective efforts have made this landmark Congress a resounding success.
I request all the members of Durgapur local center kindly come at the stage. We will have a photograph. Organizing committee, Durgapur local center, please come. All come.
Ladies and gentlemen, requesting the members of the Durgapur Local Center IEI to kindly come on the dais for a photo session. And as we disperse, may the ideas exchanged and the partnerships forged here continue to inspire purposeful action, responsible engineering, and sustained national development. We thank you all for your valued participation and wish you a very safe and pleasant onward journey. Thank you.